Good morning, and thank you for joining us today. My name is Joyce Connery. I'm the chair of the Defense Nuclear Facility Safety Board. I will preside over today's public hearing. With me today is my colleague on the board, Vice Chair Thomas Summers. The two of us currently constitute the board. We are happy to report that Dr. Patricia Lee was confirmed by the Senate as our third board member, and she'll be joining us early next month, and I think Patricia's actually watching us as we speak. I'd also like to recognize our former board member, Ms. Jessie Roberson, who's here with us today. She's the last member off the board last year. This hearing will now come to order. Mr. Eric Fox, the board's Associate General Counsel, will serve as the Executive Secretary for the hearing, and Mr. Tim Dwyer, the board's Technical Director, will provide us with the staff's perspective. Today's hearing was publicly announced on July 26, 2024 in the Federal Register. Additional information related to the hearing is available on our website, www.dnfsb.gov, or via the QR code on the agenda. This hearing is being broadcast live over the internet, and a recording and transcript will be available on our website in the coming days. Thank you, all of you, for joining us today in person and virtually. If you are a fan of board hearings and have tuned in the past, this may look a little different than previous board hearings. Our witnesses are not DOE nor contractor officials from defense nuclear sites. Rather, today's witnesses are outside experts who joined us here to provide their insights and observations regarding the management of physical infrastructure. Infrastructure weeks and infrastructure bills are familiar catchphrases in recent years, particularly here in Washington. As a society, we grapple with challenges of maintaining extensive collection of transportation and communication systems, pipelines and power lines, utilities, factories, and many other structures, systems, and components that we rely on to maintain, expand, and improve our society. It is a collection of all of those elements and many more that we refer to as physical infrastructure. Each step in our progress as a nation has placed new demands on services, utilities, and transportation systems necessary to support it. Simply look around and you can identify the elements of our physical infrastructure that we depend on to sit comfortably here today and safely while we talk. This infrastructure and its individual and collective components are vulnerable to aging and technological obsolescence, much like we are. We know that without proper maintenance, things slow down, wear out, bridges collapse, pipes burst, cars stop running, and a multitude of other bad things happen. Just like us, they might not operate or function as well as they did 20 years ago. The defense nuclear facilities we as an agency oversee are also completely dependent on the physical infrastructure that support them. Given that DOE's weapons complex has developed over an 80-year period, the physical infrastructure has also been subject to the effects of aging and technical obsolescence. In the past, the board has typically addressed aging infrastructure issues on a case-by-case basis, which is kind of like playing whack-a-mole. As soon as you fix one problem, another problem pops up. Consequently, we're taking a more holistic view of DOE's aging infrastructure and its potential impact on defense nuclear safety. As part of this holistic view, the board expressed its concern about DOE's aging infrastructure in Recommendation 2020-1, Nuclear Safety Requirements. In that recommendation, the board recommended that DOE develop and implemented an integrated approach for management of aging infrastructure. We said that this approach should include requirements and formal processes to identify, perform infrastructure upgrades necessary to ensure facilities, structures, systems, and components can perform their safety functions. The board recognizes that DOE is not alone in its struggles with aging infrastructure. Many other government agencies and private entities in the United States and abroad are struggling with similar issues. With that in mind, the board has called this hearing to invite other groups to talk about their experiences in managing aging infrastructure. I'll also note that the board understands the uniqueness and variety of facility that DOE operates and the importance of its mission. We also recognize that the missions of different elements of DOE, such as the National Nuclear Security Administration, NNSA, and the Office of Environmental Management, EM, each place different demands on their supporting infrastructure. In both cases, however, they will be relying on aging facilities and infrastructure long into the future. There are commonalities and lessons to be learned in the approaches of other organizations facing similar problems despite the uniqueness of the missions or the facility types, and we want to tease those out today. Managing aging infrastructure is not about addressing individual problems. Fundamentally, physical infrastructure is a system of systems, and as such, management of infrastructure requires a systemic approach. One must develop and implement policies, requirements, and programs that create a concrete framework for evaluating elements of an infrastructure for their vulnerability and aging. And when vulnerabilities are identified, the user must establish processes that mitigate the vulnerabilities commensurate with the associated risk. Those are my initial remarks, and I'd like to turn to Vice Chairman Summers for any additional remarks he may have. Mr. Summers?
Thank you, Chair Connery. Wow, what an exciting day. I do have a few initial remarks. I agree with you about the need for a holistic view of the management of aging infrastructure. Related to that, I would like to spend a few minutes considering the risks that aging infrastructure represent to the facilities that they support. Ideally, I'm sure that DOE would prefer to just replace the old facilities with new facilities. Who wouldn't? But we all realize that ideal solution is unrealistic after considering the cost, the time needed to do the work, and the interruption to DOE's mission that would be required. Consequently, while DOE can build a few new facilities, it must upgrade, expand, or repurpose facilities and the supporting infrastructure to meet its changing missions. Since we can't just build all new, it seems to me that the biggest challenge that we have with aging infrastructure is how do we decide what to replace, what to repair, and what to be allowed to fail. In my view, this is a risk management problem. We know that a physical infrastructure is intended to support the facilities that it serves. But can that infrastructure also be a risk to the facility that it supports? Here are a few of the concerns that come to mind when I consider aging infrastructure. First, I understand that aging infrastructure can reduce a facility's resilience. A facility's infrastructure needs to provide sufficient reliability and capacity to satisfy mission requirements while ensuring the normal performance of the safety systems. That infrastructure also needs to ensure adequate reliability and capacity to respond to abnormal events and sustain or restore the facility's mission and safety systems. However, as elements of the infrastructure age, their reliability and capacity tend to degrade. We need to know when the infrastructure's reliability and capacity have fallen below an acceptable level, and we need to know how to decide what that acceptable level is. Second, one of the principles of nuclear safety is that one should not unnecessarily challenge the safety systems, but a failure in an aging infrastructure can certainly initiate an unnecessary challenge to safety systems. As the infrastructure continues to age, the frequency of those challenges increase. At some point, an age-related failure in the infrastructure might disrupt a safety system and initiate a facility accident sequence. Direct answers to these concerns are difficult due to the complexity and interdependence of the elements of an infrastructure. But we need to understand how to control or mitigate the effects of aging and increase the resiliency and reliability of that infrastructure. And of course, any physical system needs periodic maintenance of some type, but there can be so many interdependent systems, structures, and components in a complex that the infrastructure and that a simple reactive or routine maintenance program would certainly not be effective. And most importantly, After considering all of these concerns, I am left with the impression that the most significant question that we must consider is, how does one systematically manage the risk associated with the aging infrastructure? Chair Connery, with that, I will end my initial remarks and turn the proceedings back over to you. Thank you, ma'am.
Thank you, Vice Chairman Summers. So for our first witness today, we're going to call our own Mr. Timothy Dwyer to come forward. Mr. Dwyer serves as the board's technical director. He's responsible for leading our technical staff as they conduct oversight activities. And Mr. Dwyer is the final authority responsible for the quality and accuracy of all technical products issued by the board. So Mr. Dwyer is going to be providing the technical staff's perspectives on the concerns and challenges Mr. Summers and I just outlined with regards to aging infrastructure. So Mr. Dwyer, please have a seat at the microphone and you can proceed with your testimony when ready.
Good morning, Chair Connery and Vice Chair Summers. Thank you for the opportunity to speak on this important topic. While our formal jurisdiction focuses on the Department of Energy's defense nuclear facilities, our enabling legislation authorizes us to look beyond those facilities to understand broader issues that may impact safety at DOE sites we oversee. Aging infrastructure is clearly one of those issues that deserves a broader and more holistic view to understand its potential adverse effects on DOE's defense nuclear facilities. Aging infrastructure and the difficulties in addressing it are not solely a DOE problem. These are national and global challenges that deserve sustained attention and careful study. One of the difficulties with aging infrastructure is that you rarely know when and where an age-related or technical obsolescence issue will arise. As a result, without a detailed condition and risk assessment, organizations are often forced to decide what work must be done and what work can be deferred, all based on incomplete information. Allow me to provide an example from outside DOE that I am sure is familiar to all of us. As a resident of Baltimore, this is particularly of interest to me. On March 26th this year, a large container ship struck one of the piers of the Francis Scott Key Bridge. The main span and 3 approach spans of the bridge collapsed. 6 members of a work crew on the bridge were killed. If this accident had occurred at some time other than 1:28 a.m., the consequences could have been far worse. Now, you might think I'm going to speak about aging infrastructure management as it relates to shipboard maintenance and ship's control systems. That may very well be revealed as a contributory cause in the final accident analysis, but I want to look at a more fundamental issue. The bridge was built in 1977. That's almost 50 years ago. At that time, container ships could only hold 2,000 to 3,000 20-foot equivalent unit containers. The bridge's protection systems were designed for that type of ship. But by the year 2000, container ships were carrying 6 to 7 times that number. Around that time, the state of Maryland and Baltimore invested heavily in upgrading Baltimore's port facilities to handle ships with 14,000 containers. But for the bridge, although some engineering studies were commissioned, no directed actions were identified. The accident is still under investigation by the NTSB. Their initial report indicates that the fenders protecting the bridge's piers were undersized, and the bridge itself was built with non-redundant steel tension members, which is a fancy way of saying potential single points of failure. Thus, in part, the bridge collapse can be attributed to a change in mission that altered the threat environment, resulting in the infrastructure being technically obsolete. The Key Bridge example illustrates the difficulties that DOE faces. What was missing at the Key Bridge was an up-to-date understanding of the magnitude of the collision threat and the bridge's vulnerabilities. The fact that the bridge met the standards in place when it was constructed did not mean anything this past March. The decision to upgrade the port to handle the larger container ships was a missed opportunity to reconsider the bridge's design against changing missions, revised hazards, and updated standards. Since I mentioned standards, allow me to spend a moment talking about what standards are and how they are used. DOE uses rules and directives to convey policies and requirements and guidance to the contractors that do DOE's work. Standards are the documents that describe criteria and methods that the contractor can use to comply with a specific requirement. Standards can be developed by DOE or adopted from expert committees governed by a voluntary consensus standards organization. Essentially, if a contractor properly follows a standard, then it has complied with the relevant set of requirements. This is particularly important in DOE's current situation of relying on aged facilities for indefinite periods and repurposing older facilities for expanded or newer missions. So far, our reviews of DOE's directives suggest that it does not have an adequate set of requirements and standards for infrastructure management. Therefore, my concern as technical director is how many opportunities have we and DOE missed to recognize vulnerabilities associated with aging infrastructure at defense nuclear facilities, particularly as those facilities face life extension and repurposing for new missions. We've already spoken of some of these challenges. That is, how can organizations create a framework to manage their infrastructure? How can they systematically identify and manage the risks associated with aging infrastructure? And how can they ensure that aging infrastructure vulnerabilities are identified and addressed when the facilities are changing or expanding to meet new missions? I look forward to hearing from our panelists the ways some other organizations have approached these common challenges. I hope to use the insights, best practices, and lessons learned from today's session to inform our approach to overseeing DOE's management of aging safety infrastructure at its defense nuclear facilities. Madam Chair, that ends my testimony.
Thank you, Mr. Dwyer. You may step down. So I hope that there are a couple of phrases that are going to stick into your mind and that you can keep in mind throughout the hearing, which are the issues of changing missions, revised hazards, and updated standards. And the notion that you really can't accept a risk that you haven't understood or that you haven't defined. Nuclear and other high hazard facilities and operations around the world are also dependent on the local infrastructure. This is not solely an American problem. With that in mind, I'm honored to introduce Director General of the International Atomic Energy Agency, Rafael Grossi. Although Director General Grossi could not be with us today, obviously he's in Vienna, he's graciously provided us some recorded remarks that we wanted to share with you today at the beginning of the hearing. Thank you.
You can't help getting older, but you don't have to get old. George Burns could have been talking about nuclear facilities. Ladies and gentlemen, it is a pleasure to address you on the serious topic of how we manage aging nuclear infrastructure. I'd like to thank Joyce Connery, Chair of the Defense Nuclear Facilities Safety Board, for inviting me to be part of this hearing. Aging isn't easy. Technology degradation at nuclear facilities requires strong management and careful regulatory oversight. The Department of Energy of the United States has been making continuous improvements, and I can tell you from my position as Director General of the International Atomic Energy Agency that the DOE is a role model for other countries. I'm also grateful for the way it supports us in helping others to adopt good practices too. our learning and our jobs are never done. This ethos is reflected in the series of activities the board of the DNFS has launched to keep the focus on the safety and utility of aging nuclear infrastructure. Finding opportunities to improve current protocols and to incorporate good practices by looking at the work of other relevant organizations is obviously a smart approach. Learning from the experience and the knowledge of others is also central to how the IAEA serves its member states. We focus our work on aging management around 4 main areas. The International Generic Aging Lessons Learned program collects and makes available proven good practices from around the world. More than 30 of our member states cooperate in the program, which benefits from the shared knowledge and experience of more than 200 experts. Our second area of focus is the development of safety standards and publications, which includes the analysis of structures, systems, and components of nuclear facilities. Meanwhile, our peer review services dedicated to the safety aspects of long-term operation, we call it SALTO, supports the lifetime extensions of nuclear power plants by comparing existing practices with the requirements of IAEA safety standards. We have a similar review service for research reactors, many of which are also quite old. And lastly, the IAEA conducts many international, regional, and national workshops to support member states addressing specific technical areas. There are many nuclear facilities dotted around every continent. The IAEA focuses on facilities involved in peaceful uses, like the more than 200 research reactors producing life-saving medical isotopes and the 400-plus nuclear power plants generating a quarter of all low-carbon power in the world. We know the world's climate goals cannot be met without nuclear power. Our analysts agree with those of the Intergovernmental Panel on Climate Change and the International Energy Agency in saying a lot more capacity will be needed between now and 2050. To double capacity, building new facilities won't be enough. The world will also need to extend the life of its current fleet, much of which was built between 30 and 40 years ago. For that, we will need effective aging management programs that ensure proper inspection and maintenance. Major challenges include the aging of reactor pressure vessels. When it comes to components, it can be particularly tricky to inspect and maintain those that are buried and concealed. Technological obsolescence is another notable issue. It requires finding reliable alternatives that provide the same safety function as those no longer available. But it's not only about equipment. Ensuring knowledge transfer to new generations of experts is important because the nuclear workforce is also aging. Ladies and gentlemen, a few years ago, I had the opportunity to tour Besnau, the world's oldest commercial power plant, which sits in the Swiss canton of Aargau. It was built in 1969, the year the Apollo astronauts landed on the moon. Today, the command module Columbia that brought Armstrong, Aldrin, and Collins safely back to Earth is an exhibit in Washington's National Air and Space Museum. Besnau, meanwhile, is still doing its job. But it would be unfair to say it was the same facility that sent its first pulses of electricity to the grid back in the 1960s. Its technology, management, and regulatory oversight have been renewed and upgraded over the years. And that is also true of other nuclear power plants and facilities around the world. Keeping nuclear facilities safe as they age protects precious investments. It also preserves the social contract on which the use of nuclear science and technology rests. Keeping that part of the deal is crucial to the future of the nuclear sector. I commend you for the work you are doing in this regard. With age comes wisdom, and with good practices comes longevity. Your dedication will ensure nuclear facilities continue to serve their important purposes many years from now. Thank you.
I want to thank Director General Grossi and his staff for preparing those remarks for the board. We're truly honored by his support of these efforts. And the board fully understands that the DOE does not operate large nuclear power reactors like those that the IAEA are primarily concerned about, but the IAEA regulates non-nuclear facilities as well, and same aging infrastructure concepts can be applied to those facilities. And as a Bostonian, I will apologize that my accent is not as engaging as the Director General's. Sorry about that. So today's hearing is just part of a broader campaign that the board is looking at to facilitate improvements in the management of aging infrastructure in the DOE complex. Two of the core initiatives of this campaign are this hearing and a new web-based information repository that aggregates aging infrastructure management resources. This repository is open to the public and can be accessed by either visiting our public website at www.dnfsb.gov or via the QR code on the agenda. At that site, you can explore relevant content created by the board and its staff and other organizations, as well as important papers and journal articles. Today's hearing is going to be divided into two sessions. In each session, the board's going to call some expert witnesses to a panel format. Each panelist will be given time for initial remarks, followed by questions from the board. After hearing from individual panelists, the board will lead a group discussion of that session's panelists. The first organization that we're going to hear from today is the Government Accountability Office, or GAO. As an independent, nonpartisan agency, the GAO plays a vital role in providing information and analysis to Congress. In this hearing, we're seeking to benefit from the GAO's broad expertise and institutional knowledge to inform potential enhancements of DOE's approach to aging infrastructure management. The second organization that will present this morning is the American Nuclear Society, or ANS. ANS is one of the nation's foremost standard-setting bodies for nuclear facility design, analysis, and operation. For today's hearing, we're going to draw on ANS's expertise related to aging infrastructure management in non-reactor nuclear facilities. So at this time, I'm going to call our first panel and invite our panelists to be seated. Joining me for this session are three experts from the GAO. Mr. David Maroney is the Director of Physical Infrastructure and Mission Area. Mr. Maroney oversees work on real property management across the federal government. He's also led projects in examining the nation's energy infrastructure, including federal oversight of commercial nuclear power. Ms. Allison Bodden is a Director in the National Resources and Environment Mission Area. Ms. Bodden oversees work related to U.S. nuclear weapons stockpile and has deep expertise in the operations and infrastructure associated with the National Nuclear Security Administration. And Mr. Nathan Anderson is also a Director in the National Resources and Environment Mission Area. Mr. Anderson oversees work related to the cleanup of radioactive waste from the production of nuclear weapons. Mr. Anderson has a broad expertise in nuclear operations and infrastructure associated with DOE's Office of Environmental Management. Also joining us for this first session is Mr. Todd Anselmi from ANS. Mr. Anselmi is the chair of ANS's working group that published a standard in 2021 entitled "The Process for Infrastructure Aging Management and Life Extension of Non-Reactor Nuclear Facilities." Very pithy. This standard for the session we're going to refer to as ANS 314, and I was told that that was coincidental, that it's 3.14. But we'll be referring to it as ANS 314 in this hearing. Mr. Anselmi also serves as the vice chair of ANS's Standards Board. In addition to his leadership roles within ANS, Mr. Anselmi is the recapitalization project manager for the Advanced Test Reactor at Idaho National Laboratory. Thank you for taking time out of your busy schedules today to join us. So I would invite you all to come up and take a seat behind your placard. Thank you. And Mr. Maroney, Ms. Bodman, and Mr. Anderson, we're going to start with your opening statements.
Very good. Thank you, Chair Connery, Vice Chairman Summers. Thank you for the opportunity to speak with you today. I'm happy to set the stage for my colleagues' DOE-specific testimony by first describing the leading practices that GAO has identified for effectively managing real property assets and deferred maintenance and repair backlogs. These are general practices that any agency should consider when managing their real property portfolio, but they are particularly relevant for DOE given the large and aging infrastructure of the nuclear security enterprise. I'll begin with our leading practices for asset management, which, when properly applied, can help agencies optimize how they spend their limited real property funds, as well as make more strategic, risk-informed decisions about their infrastructure. We identified these leading practices by synthesizing information from international consensus standards, studies on asset management practices, and interviews with more than 30 experts and practitioners. In many ways, these practices seem like common sense, but we found that agencies often don't apply them robustly. I'll highlight a few. First, agencies should have formal plans and policies to manage their real property portfolios. This type of governance regime can help agencies take a more strategic approach to their infrastructure decisions and provide a systematic framework for identifying their resource needs as well as strategies for overcoming obstacles. Second, agencies need to have a good process for prioritizing their infrastructure investments. Doing so enables agencies to target investments and maximize the value of their facilities to meeting their mission. Third, agencies need quality data to effectively manage their infrastructure. That is absolutely essential. We have consistently found that agencies don't have reliable data on their real property assets, including information on those assets' location, condition, and utilization. Without good, reliable data on facilities and their mission criticality, agencies can't make well-informed decisions about how to target their resources most effectively and mitigate risk. Finally, agencies need to continually evaluate the performance of their asset management framework and make changes as needed based on changing times. It needs to be a living process that keeps an agency's mission at the forefront of real property decisions. Shifting gears, another key component of good real property management is effectively managing deferred maintenance and repairs. Managing a large number of assets with aging systems that have exceeded their useful lives creates a number of challenges. In short, how can agencies like DOE best manage their backlogs to avoid mission impacts, premature replacement of systems, and minimize costs? To answer that question, we've identified several leading practices for effectively managing deferred maintenance and repair backlogs. We've derived those from more than 15 years of research conducted by the National Research Council. These practices largely resonate with good asset management in general. For example, agencies should align their real property portfolios with their mission needs and promptly dispose of unneeded assets. They should conduct regular condition assessments as a basis for establishing appropriate levels of funding to reduce, if not eliminate, any backlog. They should identify the types of risks posed by lack of timely investment, and they should employ models, when it makes sense to do so, to predict investment outcomes, analyze trade-offs, and optimize among competing real property investments. We recently reported that DOE doesn't have such a model for the department as a whole and recommended that it work with its component agencies to evaluate the costs and benefits of employing one. In conclusion, federal agencies like DOE need to effectively manage their real property assets so they can carry out their mission and achieve their strategic objectives. The leading practices I've described today are not a guarantee of success, but they provide a foundation for good real property management. My GAO colleagues will discuss next how DOE specifically is doing in managing the infrastructure of the national security enterprise. Chair Connery, Vice Chairman Summers, that concludes my statement. I look forward to any questions.
Chair Connery, Vice Chair Summers, thank you for having my colleagues and me here today to speak with you about our perspectives on managing aging infrastructure in the nuclear security enterprise. Today, I'm here to speak specifically about the National Nuclear Security Administration. I just celebrated 20 years at GAO, which is a strange conception for me since in my head I'm still only about 30. But I raise this because I conducted my first review of NNSA in 2005. That review was the first time I visited Los Alamos National Laboratory. And throughout the preceding years, I visited Los Alamos and nearly all of the active sites under the Safety Board's purview multiple times. 20 years of site visits across multiple NNSA administrators, secretaries of energy, congresses, presidential administration provides a long view of the progress NNSA has made in characterizing the challenges its aging infrastructure poses, the progress it's made at its sites, and the challenges that remain to be addressed in the coming decades. So in my remarks today, I'll focus on those two themes: first, progress, and second, challenges, which is very typical of GAO. In the 20 years that I've been supporting the Congress to oversee the nuclear security enterprise, NNSA has made significant progress understanding its aging infrastructure issues, structuring its programs and its budgets to better support maintenance and modernization of the enterprise, and beginning to address this challenge through repair, recapitalization, and replacement. With GAO, there's always a but, and my remarks today will be no exception. But before I get there, I'll take a moment to speak positively about the progress I've seen. So while anecdotes and impressions don't meet GAO evidentiary standards, I can share with you my general impression is that sites look much better now than they did 20 years ago. At that time, Y-12 had massive piles of rusting scrap metal dotted throughout the site. Pantex had constant and visible steam leaks in its above-ground piping. Los Alamos was emerging from a safety stand-down of all its operations because operational conduct had degraded. And when you visit the sites today, this impression is much changed for the better. Looking back historically, the Facilities and Infrastructure Recapitalization Program, or FIRP, was authorized by Congress to buy down, by 2013, a backlog of maintenance that was deferred before 2005. This was then NNSA's first real concerted effort to tackle its maintenance challenges, and FIRP focused on taking down excess facilities and shrinking sites' footprints. But even while these activities were being funded, newly deferred maintenance was being allowed to accumulate, and appropriate investment was not made in enduring infrastructure. As NNSA's program of record crystallized in the 2010s, infrastructure needs became clearer, as did the challenges NNSA had in its infrastructure data. In a series of reports on different infrastructure capabilities, we reported on deficiencies in the way NNSA conducted facility conditions inspections, which led to problems with data on replacement plant value, inaccurate facilities records with respect to mission dependency, and chronic underfunding of maintenance and recapitalization with respect to DOE's own benchmarks for funding these functions. Also during this time period, efforts to design signature replacement facilities began, but also stalled and sometimes died in design, subject to scope requirements or scope changes and requirements creep. We also reported on infrastructure failures at Y-12 and Pantex that came as surprises, leading to unsafe working conditions. Since then, NNSA has made significant progress improving its available data on facilities condition, standardizing an approach to facilities inspection, taking a risk-informed approach to maintenance and recapitalization investment, and structuring its budget to provide transparency for infrastructure investment. Completing implementation of the builder system, coupled with significantly improved and integrated master asset and area planning, will pay dividends in the future. Similarly, NNSA has made strides addressing balance of plant and safety system issues with improved roads and utilities and fire suppression. NNSA has also made progress planning for facilities replacement. Its process for identifying and prioritizing line item construction efforts is systematic and risk-informed. But here comes the but. While NNSA is finalizing efforts to put in place a sound infrastructure planning framework and has made strides in wrapping its arms around maintenance and recapitalization needs, its infrastructure is still aging. Given its ambitious program of record and the current security environment, NNSA does not have the luxury to pause operations for infrastructure work. Further, major construction efforts to replace or modernize critical facilities are delayed. And because time is money, these delays have significant knock-on effects with respect to NNSA's portfolio investment strategy. More specifically, as we identified last summer in our first effort to report on the status of NNSA's portfolio of major construction projects, Collectively, its projects were about $2 billion over their baseline cost estimates and 10 years over their collective baseline schedule estimates. Of 10 projects that were still in design, 6 were in the process of significant rescoping, some resulting in project pauses. The largest contributors to the overall cost and schedule overruns were uranium processing facility-related projects at Y-12, and a project there is awaiting a rebaselining now. Schedule delays and cost overruns on major replacement projects have myriad implications for the infrastructure portfolio more broadly, and I'll touch on just a few. So when replacement facilities are delayed and mission work cannot be deferred, NNSA will have to operate in aging facilities for longer than planned or desired. This compounds the costs of delays because not only do construction costs for the replacement facilities increase, but also NNSA must spend money to maintain and reduce risk to continue operating the facilities slated for replacement. Nowhere else is this more true right now than at Y-12 with the UPF building, and I know we're likely to talk about that more later in the day. Also, when the costs of ongoing line item construction projects increase, funding these projects crowds out other priorities and may lead to suboptimal or less transparent approaches to work. Notable examples of this are decisions to pause several construction projects that NNSA had previously argued were critical to replace outdated facilities. Perhaps less obvious other outcomes with significant financial implications are decisions to invest in recapitalization in order to delay replacement, when from a mission perspective, nearer-term replacement may be more desirable. There are several projects that are experiencing this right now, and while the choices may be expedient to deal with budgetary pressures, committing a high level of recapitalization funds annually for 2 decades, for example, for a given facility, puts a load on the recapitalization budget, making it less likely to absorb emergent needs. We also sometimes see changes in project strategy and scope to access funds outside of line item construction, either because the projects needed won't fit in that budget wedge or because NNSA thinks they may be able to be completed faster without following processes laid out in DOE's project management order. Our position has been that while this approach may certainly allow projects to start sooner, it's unclear that they'll finish faster. In closing, NNSA has made progress improving its infrastructure data to better characterize and understand its infrastructure needs and remaining challenges. Transparency in budgeting and spending on maintenance and recapitalization have also improved. But the real challenges of managing aging infrastructure remain, and programmatic and budgetary pressures exacerbated by delays in replacement projects merit the board's attention. Thank you, and I look forward to your questions.
Thank you, Chair Connery and Vice Chair Summers, for organizing this hearing and inviting GAO to attend. Mr. Dwyer talked about 1977 as the year that the bridge was built. It was an important year in my life. It is not almost 50 years, 47 years ago, 1977. I just want to make that perfectly clear. I can't quite conceive of that being almost 50 years. My testimony today is focused on DOE's Office of Environmental Management, and we'll touch on where EM has made progress, the effectiveness of available tools, and where vulnerabilities persist, and oversight attention may be warranted. Now, some stage setting. DOE's infrastructure is aging and vulnerable, and its condition is likely worse than what existing data shows. A quick mental tour around the EM complex reveals key infrastructure at Hanford, Savannah River, and WIP, all operating well past their design lives. We found in 2022, base operations accounted for nearly half of EM's $7.5 billion budget, much of which was for surveillance and maintenance for aging infrastructure. And at Oak Ridge in Idaho, the costliest operations activities were for surveillance and maintenance. Now let me first speak to progress. GAO has long advocated for programmatic and risk-informed approaches, encouraging DOE and EM to view its responsibilities through a lens that looks across sites and beyond the next budget year. Applying this lens has allowed EM to accelerate cleanup in certain instances. For example, accelerating L Basin de-inventory at Savannah River will save about $4.5 billion in life cycle costs. EM has also recently taken steps to apply a more programmatic approach to the disposition of excess facilities. In recent years, EM has integrated its lists of facilities prioritized for disposition with all NNSA facilities that meet EM's transfer requirements. Applying leading practices for program management and risk-informed decision-making has resulted in accelerating the cleanup schedule of certain facilities and has already saved DOE more than $50 million in avoided surveillance and maintenance costs. Now I will turn to the tools that DOE uses, and the bottom line here is that the effectiveness of available tools is bound by DOE's and EM's willingness to use them as intended. First, surveillance and maintenance. In our 2020 report on aging infrastructure at Hanford, we found EM had not ensured that requirements were fully met regarding the Hanford contractor's routine surveillance inspections of contaminated excess facilities. We found that surveillance and maintenance inspections at several facilities were not comprehensive, and there were areas of some facilities that personnel infrequently or never entered, either physically or by remote means. Now, extent of condition reviews. In our 2018 report on quality assurance at the waste treatment and immobilization plant, we found that DOE had not ensured that all WTP quality assurance problems were identified, and some previously identified problems were recurring, such as the procurement of items that did not meet nuclear quality requirements. DOE's quality assurance framework requires the contractor to determine the extent to which quality assurance problems exist in all structures, systems, and components when problems are identified. However, DOE did not direct the contractor to determine the extent of such conditions at the WTP. Root cause analysis. DOE uses root cause analysis to find out what happened, why it happened, and determine what changes need to be made. In the wake of the Purex tunnel collapse at Hanford, DOE waived this requirement for the contractor to perform a root cause analysis and instead allowed a less rigorous analysis of the potential physical causes of the event, limiting DOE's assurance that another similar event will not take place. And finally, corrective action. In our 2022 report on WIP's capital asset projects, we noted that DOE identified 2 root causes for cost increases and schedule delays in its project to install a new ventilation system. Some corrective actions were taken, but the extent to which the actions would address root causes was unclear. Because DOE was not required to develop a corrective action plan for addressing the root causes and did not have a process to verify the efficacy of corrective actions. Now I'll turn to the vulnerabilities and where additional oversight may be warranted. The first organizational vulnerability I want to touch on is information quality. Actual conditions may be worse than data show. We found in 2023 that as sites develop their integrated priority lists, infrastructure needs that are not within the funding profile provided by headquarters are moved to future planning years, rather than identified as an unfunded priority for that particular year. The second vulnerability is exemptions to requirements. DOE and EM have granted exemptions to requirements for things like EVMS certifications, federal project director certifications, and in the examples I just shared, tools such as root cause analysis and extent of condition reviews. Our July 2024 report showed that exemptions are correlated to problems. EM had exempted certain requirements for each major project with cost and schedule rebaselines, whereas fidelity to requirements was correlated with effective project management and projects staying on cost and schedule. Exemptions to requirements are an indicator of needed oversight. The next vulnerability I want to touch on is workforce capacity. EM has well-documented workforce shortages, including in mission-critical positions. Certain sites are particularly understaffed, and gaps in mission-critical positions can illuminate where additional oversight of aging infrastructure may be needed. There's an 18% vacancy rate for 14 mission-critical job series in EM. 44% of EM's workforce is eligible to retire by 2030, and attrition is 31% higher at EM than across the federal government in terms of averages. Now, the final vulnerability I want to touch on is independence. If groups at the site offices responsible for quality assurance and environmental health and safety are subordinate to those responsible for cost and schedule, red flags might not get raised. We identified such concerns with organizational independence in our 2018 report on the WTP. Now, to its credit, DOE and EM addressed this at the Hanford site and modified the organizational structure so that the quality assurance function was independent of those responsible for cost and schedule performance. It is unclear if DOE has ensured that all sites did this. In conclusion, you are doing the future a favor by shining a light on this issue now. Pointing the light at areas where available tools should have been used but weren't, and where their use may be limited by structural or organizational impediments, is a necessary and valuable public service. I look forward to your questions.
Thank you. We're going to, first of all, I appreciate your excellent and insightful remarks. And a couple of themes, I think, that I noted from your comments. One, progress has been made. It's been uneven. that there are always trade-offs to be considered. Prioritization is always a challenge. We have the issue of the loudest duck, who needs the money now, and for what purpose. Also changing missions and increased mission needs. The conversation about new facilities would be preferable to the old facilities, but that is also not necessarily in the decision wheelhouse of a particular agency. And we didn't mention the other factors such as COVID, supply chain challenges, and, we won't talk about continuing resolutions being a problem with Congress for any of our staffers who are watching. And then staffing issues, which there's a limited pool of people who can do this work, and we heard from Dr. Grossi that there's a demand for this expertise, and we don't necessarily have the funds to pay for those folks, particularly if they're at sites that are less desirable. So I think those are all factors that we can consider as we move forward. So we're going to ask you some questions and get into a dialogue. And just in case anyone's watching for time, we're ahead of schedule, mostly because a lot of us talk quickly. So I'm going to start with Chair's prerogative to ask a question, if you don't mind, Mr. Maroney. Several of your opening statements mentioned the GAO high-risk items. At the beginning of each Congress, GAO publishes a high-risk list that captures programs and operations vulnerable to management problems or in need of information. In the most recent high-risk list, which is hard to say, by the way, it includes managing federal real property and acquisition of and program management for DOE's National Nuclear Security Administration and Office of Environmental Management. Both long-standing high-risk items are relevant to DOE's management of aging safety infrastructure. In recent years, GAO's physical infrastructure mission area has identified and applied several leading practices related to managing federal real property. You illuminated some of those in your remarks. Since identifying and benchmarking best practices is a key goal of the hearing, can you share just a little bit more about GAO's approach to identifying those leading practices and the sources you draw on for those leading practices?
Sure. And we follow a typical process. We have many sets of leading practices, but we follow the same process with both our asset management and our deferred maintenance leading practices. So for the asset management, we first looked for what are some consensus standards that are already out there, what are existing practices. In this case, we looked at ISO 55000 on asset management. We also do literature reviews, so we look at studies that are out there on the relevant topic, in this case, asset management. And then finally, we interviewed a group of over 30 experts and practitioners to get a wide range of views and synthesize those three sets of information to come up with those key practices I laid out. On deferred maintenance, we did something similar, talking to experts, but also in this case focusing on National Research Council reports that have been done over, spent about 15 years on federal facility maintenance. And again, looking what's out there and trying to synthesize it into a small set of practices that apply to federal agencies in particular.
Okay. So you mentioned the National Research Council. Is there any areas related to aging infrastructure management that would benefit from further study from them or from one of the other national academies groups that you can think of?
So I'm not familiar with the full set of studies, but if they haven't already done one, one thought is simply what are some strategies for managing aging infrastructure in a constrained budget environment? There's always constraints on budget, that's not new, but as we move forward in what are likely to be even more constrained times, it's really important to get what are potential avenues to take there? What are potential strategies to balance recapitalization, repair, investment? So I think that would be a possibility if they have not already done so.
Appreciate that. Mr. Summers?
Thank you, Chair. Thank you, Chair Connery. Now we've had a chance to talk a little bit about identifying some of the leading practices. Now I'd like to switch to implementing some of those leading practices. So GAO's Physical Infrastructure Mission Team has evaluated the management practices of various government agencies, including DOE, against established leading practices. So my first question, Mr. Maroney, is, would you describe any areas where DOE lags in implementing leading practices related to aging infrastructure management?
So Our most recent report on asset management did not include DOE, but we did include them in our report earlier, well, at this point last year, on deferred maintenance leading practices. And we found that DOE actually generally speaking followed most of the leading practices we applied in that work. Important context, our focus was on Office of Science, but we did look at DOE overall, so I think the lessons still are relevant here. The two areas we found where DOE could improve, they had some partial alignment with the leading practices, were related to how they structure their budget, how they communicate information to Congress on their deferred maintenance. Now, NNSA includes a lot of information on deferred maintenance, but there were some ideas for improvement in terms of funding needs, what are the most critical deferred maintenance items to highlight that for Congress. And then the second leading practice where they only partially aligned was on the use of predictive modeling. Again, the individual agency components do use models. They do have tools, so they may in this case, but we felt overall there is a potential value in expanded use of that where you, again, analyze trade-offs of different investment decisions when you're trying to tackle a large maintenance backlog. Those kind of models can be useful. So we didn't recommend that they adopt those per se, but we did recommend that they evaluate the cost and benefits of doing so and consider whether it might make sense to use greater use of models.
Thank you very much. My second question is, in the areas where DOE still needs to fully implement leading practices, did any other agencies stand out as models of effective implementation?
So I wouldn't call any particular models on this front. GSA did, so as context, when we evaluate against these leading practices, we're looking at, does the agency have the policies and processes in place? We're not evaluating the effectiveness of once they actually implement those practices. GSA, to its credit, has developed a model for its infrastructure to do predictive modeling, again, to figure out where it makes the most sense to invest its dollars for maintenance. So that is an example of an agency that would be worth DOE talking to, finding out what they're doing, and seeing if it makes sense for DOE's case. So I wouldn't necessarily say they're a model. We just haven't evaluated that, but I do think it's worth pulling on the expertise of other agencies that have used these models in a more expanded way to see if it would be applicable at DOE.
Thank you. Now I'd like to switch gears a little bit, and this applies to the entire panel for GAO, and talk about some of the tools, some of the models and data for prioritizing the infrastructure investments. So a leading practice identified in GAO's physical infrastructure reports involves using models to evaluate between competing investments. So for all of our panelists, as DOE and NNSA work to address aging infrastructure and modernization needs in a budget-constrained environment, how do you view the effectiveness of DOE's tools and models for understanding infrastructure needs and prioritizing among competing investments?
Certainly, I can start for NNSA. Work in progress is how I would characterize it. Historically, NNSA had relied on data coming out of the department's facilities database, which wasn't really intended for prioritization decisions. It was intended to capture condition information and, basically inputs to an analysis, but not really for modeling or for making trade-offs. The systems that are under development and are expected to complete implementation within the next several years are significant improvements on that data. The builder system is making use of real-world data on how assets perform in their environments, rather than just sort of what the manual says about when to replace HVAC or the life of a roof or other things like that. And so that real-world condition information is critical in terms of making those kinds of trade-offs. We believe that full implementation of that system will pay dividends in that decision-making process, just not complete yet.
Yeah, I'm happy to add on the EM side. EM is a little different here in that it is supposed to smartly and efficiently reach the end of its existence, right? Like that's what EM is about. EM as a whole could very much benefit from an optimization model that's not just excess facilities, but groundwater and soil remediation and tank waste treatment missions. And if all of that, I mean, that should probably be the foundation, of EM's future, is what does a complex-wide optimization model show? And then with acknowledging you have different regulatory frameworks and different agreements with states, where can you push, where can you pull? In a lot of our work, we've found that if EM comes to the table with a state with a smarter way of doing business and is very upfront and transparent with that information, in many cases, states have the authority to kind of depart from what might be the constraint of a regulatory framework that it's employing to do something different. But EM needs to be sharing that information, with the states that where perhaps the status quo needs to be, revisited. I would add that in the EM context, certain sites like WIP that had a run to fail, setup, all of a sudden are not going to fail. Right? It's an enduring mission for quite some time. WIP is going to last much longer than originally intended. And when you've got contract structures that are 10-year contract structures, well, the contractor is going to do what's in the contract. It's not aiming for 2070 or 2080. It's aiming for the end of the contract. And so I think EM needs to be real smart about integrating, the long-term likely mission needs with shorter-term contracts to make sure that things that have to happen for a 2020, 2030, 2040 type design life, 20, 30, 40 years out, get the attention they need now and in kind of within the term of what might be a much shorter contract, if that makes sense.
Thank you. My second question for the panel is, in Mr. Maroney's remarks, he mentioned the importance of quality data in order to effectively manage infrastructure. So how do our GAO panelists view the quality of data that is used to support DOE decision-making in infrastructure management?
I think with NNSA, similar to my prior response, it's a work in progress and not yet fully complete or consistent with respect to the full data set needed to make these kinds of decisions. An additional challenge when it comes to aging infrastructure is always sort of the emergent priority. And if you have a situation where you have a flood, or something breaks unexpectedly, how quickly can you reprioritize? And that is a significant challenge in terms of everything being a priority at the moment within the complex, but also because there's some inflexibility in the way that the budget is structured that sometimes requires resources to be site specific, makes it challenging to move money around. And so I think in a resource constrained environment, looking at some of those options coupled with improved data and the ability to access it very quickly when needed will be very important.
On the EM side, I think that surveillance and maintenance costs are pretty well known, and EM is definitely improving in optimizing for like excess facilities, for example, how they rack and stack the facilities that they will need to take responsibility for disposition. But overall, I do think that beyond excess facilities, there needs to be better visibility into information quality for the out years. They got a good handle on the next budget year, but again, like I mentioned in my statement, if some of the information is left off those unfunded priority lists, if it doesn't meet the headquarters funding profile, and at the end of the day, Congress needs to be aware of that. Decision makers need to be aware of that data that's left out of the next budget year.
So I just had a quick follow-up, kind of based on something that you said about the prioritization and the aging infrastructure. The models are only as good as the data that's put into the model, right? And so you also have different contractors potentially putting different data in, so there's maybe not a consistency which will impact your prioritization. But to your point about emerging challenges, the emerging challenge could be from an externality, from a hazard. So your hazards are changing as well. So you're going to have to be adaptable in terms of your prioritization, also recognizing that your hazards are changing. Weather conditions, fires, for instance, may be an issue at a lot of DOE sites at this point in time, severe weather events. So how do you compensate for that in those scenarios?
It's a very significant challenge. There have been several fire scares only just recently, and in the not too distant past, flooding as well. I think one of the things that we're seeing is an overall approach to reducing risk within facilities that may not be related to aging or deferred maintenance, but things like lowering the material at risk in a facility to a point where if there were, an emergency, the risks, resident in that facility would already have been reduced. Ensuring that there's appropriate investment in things like fire suppression, emergency lighting, especially in these older facilities that may not meet modern safety codes, but making those investments in advance so that if there is an emergency, the facilities are better prepared to face them.
Thank you. As we talk about data, it comes to mind the quality and the timeliness to make sure that the data is of high quality, but also timely in time to be able to make decisions that are accurate for the enterprise. So my third question to the panel is, finally, have our panelists observed any major differences in the effectiveness of tools and models or the quality of data used across different program elements of DOE? For example, are there significant differences between the National Nuclear Security Administration and the Office of Environmental Management?
I'm trying to think if we've made that specific comparison. I'm not sure that we have. What I will say is that there are some databases that are in development in NNSA that would be very useful to export throughout the department. There are databases like this G2 database that's coupled with the Builder system that really allow facilities managers to drill down, especially as this data begins to mature in the next couple of years, to look specifically at individual building systems to understand that same system throughout a site and can help with that prioritization. Even though, as Nathan said, EM's mission space is different, it is certainly operating facilities for the next several decades and might benefit from that sort of data availability.
And if I could just add to that, we have done a deep dive at a number of the data systems that EM has, and have been able to pull data that is certainly, what we would view as reliable or reliable enough. I think the question we have, and we have some ongoing work in this space, and so we don't have a conclusion on this yet, but I think it's a valid question to ask is, how is that data used for management purposes? How is that data used for prioritization? If the data is there but rarely accessed, or there's not a process for pulling recent data before a management decision is going to be made, then that indicates there may be an opportunity for improvement.
Thank you, panelists. And I will now turn it over to Chair Connery for follow-on questions.
Thanks. So DOE and NSA facilities have a large backlog of deferred maintenance and repair needs, which you've all alluded to. And you guys have talked about deferring maintenance and repair costs can reduce the overall life of the facilities, lead to higher costs in long term, and pose risks to safeties and agency's mission. So this is, I think, a quote from one of your documents. So given that, how do you guys look at DOE's management of deferred maintenance and repair backlog in NSA and DOE? Like, what do you think? I've heard you say that there are improvements, but what else can be done?
So just at a general level, I'll let Allison and Nathan speak to those specifically, but we did look at, as I mentioned, DOE as part of our recent work on deferred maintenance. And we found, again, it's really higher use of modeling, better modeling. Data, as we've discussed, is always going to be core to that, and better communicating to Congress what the highest priority needs are in a couple of ways. They did align, again, with a number of our leading practices, but I think when you get drive into the details, that's at the departmental level and at Office of Science. So Allison and Nathan, I think, can speak more directly to NNSA and EM.
With NNSA, firstly, now there are dedicated maintenance and recapitalization budgets, which is a significant improvement on things in the past where that level of support wasn't as transparent, and it was more difficult to understand what was being funded and what wasn't. What we do see is a lot of this work is now being projectized, which is a way to oversee it and to see how much money was planned for something versus what it actually got. DOE does have kind of benchmarks for funding for recapitalization and maintenance based on replacement plant value. And so in some ways, it's very important to make sure that that replacement plant value data is accurate so that you can understand whether you're meeting those maintenance and recapitalization budgetary thresholds. If that RPV is off, if something seems like it's worth less than it actually is, your maintenance and recapitalization budgets won't be sufficient. So some of the work that's going in right now into improving the data, and hopefully we'll have an opportunity to look at this in the coming year, is how are those condition assessments being done to make sure that that replacement plant value data is correct. And that's the basis for understanding if you're sufficiently funding recapitalization and maintenance and you're buying down your deferred maintenance. So, yeah.
Yeah, and if I could add on to that on the EM side, EM has not projectized this in the same way that NNSA has. In fact, a lot of EM's activities are now called operations activities and are governed by the program management protocol. About 75 to 80% of EM's budget is outside of project management space. We have long advocated for project-like controls on virtually everything EM does. And recently, with the implementation of their updated protocol, the EM has included more project-like requirements, which would allow for this data to be clearer, for there to be more consistency across sites. I'm going to a slight pivot here. One thing that we've seen is where there is good data and where there on things like deferred maintenance and surveillance and maintenance costs, and where there is a little bit more of a holistic approach looking across sites, good things can happen. Accelerated cleanup. And Congress has appropriated additional funds for accelerated cleanup when you can show that, okay, spend $1 today to avoid spending $10 over the next 10 years. So there can be those kind of trade-off decisions that are beneficial to the taxpayer and beneficial to the complex if that information is shared.
So related to that, can you talk a little bit about maintenance versus, say, recapitalization, and if there are any best practices surrounding that? Do I need to clarify again?
So I can start off again at a general level. We have capital planning leading practices, which I think come into play there, which is, you need to do a needs assessment. What is the need you're trying to accomplish here? You need to weigh a wide range of alternatives, which could be recapitalization, which could be some other approach, consider the trade-offs, prioritize, and then have a long-range plan. So that is just basic capital planning best practice. How it applies in EM and NNSA space, I'll turn over to my colleagues.
So in NNSA space, there's this sort of very interesting dynamic and trade-off between making a maintenance decision versus a recapitalization decision, which can often be mission-based. In NNSA, there's a lot of, for example, production equipment that's very, very old. It's not production equipment that one could even buy again. And that has to do with the processes for manufacturing components, for using specific materials that are proven over the long term in terms of the performance of the stockpile. And so in many cases, it may be more desirable to maintain that very old equipment or that old building system that you understand performs in a specific way in conjunction with your production equipment, rather than recapitalize it, because recapitalization, exchange of parts, it might actually compromise the way you understand the performance of something. That's obviously a very different type of decision than maybe for a building system or a safety system. But NNSA is often faced with those kinds of choices about whether to maintain something very old because its performance is well understood versus recapitalization or replacement. The risks need to be accepted in those cases by either facilities managers or by the folks who own those production processes to make those trade-off decisions with really good understanding of the performance coming out of those systems.
So in your example, is there room for maintaining the old equipment, but still working in case that piece of equipment fails to have a replacement when it reaches its end of its life? I mean, I think that's the problem, is you can't predict run to failure.
Very true. And there are any number of examples of single point failure in the NNSA complex. In some cases, redundancy would be desirable. Well, I would say in all cases, redundancy may be desirable. In some cases, it may not be available. And that's a very, very challenging aspect of this for this enterprise.
Short answer here on the EM side, that I can probably illustrate a little bit with an analog. Out at the Hanford site, looking at the waste treatment plant, you've got multiple melters in the DF law program. You've got the high-level waste facility is currently conceived, have multiple melters. DOE in the recent consent holistic agreement that came out is now able to use a parallel path grout for 22 tanks in the west area. That kind of redundancy, I think, is going to be very, very helpful. If something goes sideways with the WTP, still having a parallel grout operation will allow DOE to continue with the waste treatment mission. And I think you're going to see that in the EM complex, maybe fewer like big box models where you have to be having this conversation, and more smaller, modular, parallel paths for treatment, helping to ensure that EM doesn't have to rely on one particular technology or one particular facility, where that if it gets paused, like pre-treatment facility, for example, for 10, 12 years, you significantly delay the schedule and significantly grow costs.
Well, that's also an example of where they kind of showed their hand to the state, and then the state was able to move on the compromise. So that's a good example. So I could ask questions for the next couple of hours, but I'm not going to do that because we have another panelist. So I want to thank you for your time and sharing your wide-ranging perspectives on managing federal infrastructure and DOE's related challenges. But I want to make sure that we give Mr. Anselmi from the American Nuclear Society a chance for his opening statement, and then we'll pepper you with questions.
And I actually put together words and pictures, so I won't just talk out to you only. So this is an introduction, and I think you heard the title of 314. It is a long title. It's like going to Starbucks and ordering a very long coffee title, right? So next slide, please. I wanted to bring up the ANS Standards Committee because I think Mr. Dwyer brought up the fact of a standard, right? If you saw the title of the ANS 314, it's preceded by ANSI. So what that means is that all of the standards design organizations in the country, including mechanical engineering, civil engineering, they go through a process that's certified, which states that the standard goes through multiple organizations of review. But the more important thing is at some of these committee levels, we maintain a balance of interests. So we have both experts, we have the folks, the stakeholders that have to implement the standard, And then even in accordance with the Office of Management and Budget, Circular A119, which states the federal agencies, especially the oversight agencies, have participants in these consensus standards as well. So we try to maintain a nice cross-section of folks and expertise so that it gives you the best product that can be implemented. Next slide, please. So I'm not going to tell you how 314 implements aging management, but I'm going to talk about how or what it does, especially for the end user. But one important aspect early on, and credit to DNFSB and staff members more than 10 years ago, one of the staff members proceeded with a review of, do we have something in the DOE standards and orders and guidelines for aging management? And as a result of that, the individual put together a project identification. I can never remember what our PIN standard, and I'm the vice chair of A&S standards, I should know those, but put together a project approval to start developing this standard. So the middle bullet there provides a methodology to evaluate the site and facility infrastructure processes and physical conditions. And then we list some of the typical pieces of equipment that might be under this document. Next slide, please. So I think, especially for those who are very familiar with a nuclear facility, not just reactor, but also non-reactor, there are thousands of pieces of equipment. Now, not all of those pieces of equipment are important. I should, I'm going to use that term "not important" because there's a lot that I'll use in the term of roads and commodes. Right? We do have the ability to allow some of those facility aspects to age a little bit differently, and we address them without upgrades, standard replacements. And not all of them affect the long life attributes of a facility. So the scope of the document actually focuses on, and we use the term sometimes passive and active, but here it's passive. You've designed the facility, you know that the age of either the building or the building aspect, like a support to a pipe, is going to live and operate for more than the time that you've expected it to operate. Well, now we're operating more than the time we've expected to operate. So those are the ones we want to concentrate on because they didn't get normal maintenance and activities associated with your normal operation of a facility. So everything else is not in scope. Next slide, please. So 3 important aspects of the 314 standard is we do provide a process for scoping and screening. Then the identification of degradation mechanisms and aging mechanisms. And I'll talk a little bit more about that because that's really important here. And then we develop a aging management program. So I think I heard from my associate panel members here, we talk about a risk-informed process. So we have a process for scoping and screening that does implement some risk-informed. It's not like what some facilities with a reactor would, an operating reactor incorporates a probabilistic risk assessment, which a lot of numbers and a lot of event sequences, but something pretty standard. And then the degradation mechanism identification. And then I think I heard also condition monitoring. So an aging management program is going to focus on, well, what should I go look for and what are the indications that I should then be concerned about and take action on. Next slide, please. So from a selection standpoint, and we made this, I won't say simple, but more simple than it could be, where we focus on those items on the check marks to the right. So you start with the whole entire system and you start to down select to say, well, what's important? So from a safety importance standpoint, and when it says facility outage, that's also a different term for we have a mission. Okay, our facilities have a mission to do ABC, and anytime that a component, whether it's a safety component or not, once that component goes down and affects our ability to perform our mission, that gives some level of importance from a screening process. Then you can establish a dollar value, whether it's a recurring issue you've had issues with constantly, and then finally the management discretion. You do want to have that extra. Hey, you know what? From a strategic standpoint for our mission, we want to incorporate that equipment in the program as well. Next slide. Review for aging mechanisms, aging and degradation mechanisms. And I want to talk about the U.S. commercial nuclear power plant. That is my background. We, as an industry in the commercial side, put together this generic aging lessons learned, and I think you heard Dr. Grossi from the IEA bring that up because they have an international GAL that's been published for that as well. And 2 volumes, the new regs, are pretty thick. And what that has done is gone through all of the aging mechanisms that components throughout all the commercial nuclear plants have endured or they see in their normal operating environment, and essentially textbooks all of what you should go look for. And in some degradation mechanisms, you might have 5 pages of different, well, if it's in this kind of operating environment, if there's this kind of material. So it's all there. And when I talk about this subject with a lot of other folks, I said, it's not just a commercial nuclear reactor. And I've had discussion with non-reactor facility maintenance people. The equipment in a lot of cases are identical. I mean, even equipment numbers, motor-operated valve actuators are very similar. The big difference is the commercial plants have neutron degradation that your non-reactor facilities won't have, right? But everything else, I even say that a paper factory can apply all of it. It's very good engineering judgment, and it's all there already. So that process was very well demonstrated in the commercial industry, enough to support extending operating licenses for commercial reactors now up to 80 years. So next slide. Then the aging management review, when you take all that data, you say, okay, here's what I need to look for. I think I already mentioned that, what I need to look for and how to look for it, how often to look for it. So we put together a performance monitoring and an aging management program where it says, okay, on a 5-year basis, I'm going to go look at the foundations of a building, and I'm going to look for this sort of degradation. You also assess the ground quality as far as your water. What's the pH in your groundwater? How does it affect the building foundation? So that goes through a big process to then put together a program document. And I list a couple of things here that some facilities may already have. Predictive and preventive maintenance programs, which is the standard maintenance type of thing we've talked about. And a lot of that's based off of your operating environment and your operating condition, or your duty cycle, how often the equipment is called upon to perform its function. System health monitoring, the trending program, performance monitoring, spare parts obsolescence, which components or which pieces of equipment or components should have spares, and which ones we can afford from a logistics standpoint, which ones might actually, you can just go order from your vendor on a short-term notice. And structural monitoring is one of the big programs, because a lot of times the structure, you got to go and actually remove coatings to look at the concrete underneath, focus on areas of where your structural supports mate with the building itself, where you could be getting rust underneath, things like that. Next slide. And then we, as part of the document, and our appendices aren't part of the standard. They're in this case, they're an example. So one of the facilities provided a portion of what they call their extended life program. So we do have a couple of appendices for, okay, how do I assess the risk of not implementing that aging management program or that equipment replacement, the risk associated with the overall mission of the facility, not just that component specifically. So there's a good example of how they did that risk and prioritization, as well as now how did I incorporate it into a larger long-term program for extending the life of the facility. So that was just what I had for the prepared remarks.
Well, that was fantastic, and we'll have, like I said, some of this information will be available on our website, so if you didn't memorize those slides, they will be in the record of the hearing, and you can go back and look at them. But we're going to ask you a couple questions based on your expertise in this area, and then we'll have a bigger group discussion. So in ANS 314, the standard addresses aging infrastructure management for non-reactor facilities, as you noted. For members of the public viewing this hearing, nearly all of DOE's defense nuclear facilities under the board's safety oversight are non-reactor facilities. hence our interest in this standard. DOE and NRC both have existing regulations that apply to non-reactor nuclear facilities. Given that, what led ANS, other than one of the DNFSB staff members, to create a new standard for managing aging infrastructure in these facilities?
What led to the?
Yeah.
And again, I think
What was the need? What was the need for it?
That was a need for the aging facilities, especially under DNFSB oversight, that they didn't have a process that was built specifically for those facilities. And at that time, I don't think, the team, the working group may not have been aware that everything else that we do as a nuclear industry or even other engineering facilities, engineered facilities, have a lot of the same degradation mechanisms. So at that time, the driver was, we need something specific. But also from a regulatory standpoint in DOE, it's better to reference DOE-based standards and not just something generic to a reactor facility.
So a logical follow-up is, who do you envision using this standard? Defense nuclear facilities at DOE, or is it broader than that? Who do you think the end users will?
Actually,
or should be?
those are an obvious, that was kind of the target for this standard. But other DOE-regulated facilities could include, and I've done some recent work with the isotope production folks.
Okay.
They have facilities that have a lot of the same degradation mechanisms.
Okay, thanks.
Thanks, Chair Connery. I'd like to now pivot to the topic about expertise and the expertise that you were able to use to help contribute to the ANS 314 development. So, Mr. Anselmi, the ANS working group that you chair includes a broad range of expertise. Can you describe the expertise and professional affiliations of the individuals on the working group that, with your leadership, authored the ANS 314 standard?
Yeah, from an agency standpoint, it included both the Nuclear Regulatory Commission. We had folks from the Department of Energy, and at that time we had a DNFSB staff member on the board. But then we include some additional vendors, one from a structural expertise standpoint, and that individual, and then later two individuals, supported the American Society of Civil Engineering, myself from the American Society of Mechanical Engineering at that time, as well as ANS, because of that experience with the commercial nuclear reactors. And then actually we had up to three people at one point from the Department of Energy. So if you go back to my first slide where I talk about the need to have a balance of interests, that way one interest doesn't have more, so the DOE wouldn't have more interest or more drive or more bias on the development of that standard, but also your end user doesn't have the end bias. And then we had at least two folks from two different of the regulated facilities as well.
You had a broad range of expertise to contribute. That's great.
Yep.
As a follow-on, can you describe, and you mentioned briefly about this, can you describe the formal review and vetting process that you used to approve the issuance of the ANS 314 standard?
Yeah. So also on that first slide where it shows the different levels of committee, I can tell you that at our working group level, this is a volunteer organization. So all of your standards design organizations have mostly volunteer supported by staff as you process the document. But our folks, we did take a while to get the standard out at our level. We did have a lot of good critical discussions on what the document should entail. And part of that also, you want to provide a standard that has a lot, I'm going to use the terms shoulds and shalls, because you don't want to provide a lot of shall statements in a standard that aren't integral to the successful completion of what you're trying to implement. In this case, aging management program, aging management review. But you also don't want to leave it fluid that it becomes a not so efficient or effective document to implement. So at that level, we spent actually several years putting together this document, and then it goes through, I think we probably, I've had some documents at ANS have over 100 comments when it goes up through the next levels of review. So you start incorporating lots of different expertise, sometimes not even directly related to your area that you're trying to develop, but that can be beneficial because then they look at it with different set of eyes and can be different and more critical about things.
Very good, thank you. Thanks for sharing. Next, I'd like to talk a little bit about regulatory influences. The ANS 314 standard frequently cites the NRC's generic aging lessons learned for subsequent license renewal, or GAL-SLR, that report. So my first question is, did any other existing regulations or best practices serve as models for the aging management framework that was codified in ANS 314?
Yeah, no, that's a good question because at the time, we did have a couple of our participants were developing their aging management program, aging management review, and life extension for their facilities. So we utilized their expertise, and that would include the sites of Savannah River and Y12. And as they were developing their programs, it was an opportunity for the working group to challenge what they were implementing, as well as taking, well, what is working effectively at those facilities and implementing that as kind of goes back to a lessons learned while we were learning it and able to incorporate it at time of development. So there was a key part of that in developing the standard.
You had mentioned Y12 and Savannah River. To what extent did the working group consider other existing or the existing sites that you mentioned? To what extent did the working group consider the existing DOE requirements when developing the 314 standard?
So those individuals would incorporate some of the existing regulation, but when you include the folks from a vendor or service provider, an engineering service provider, they have experience in other, not just other industries, but other facilities as well, and that they were able to bring. Now, I can't cite what those other facilities might bring, but that was part of developing the right team to put together the standard, is what they bring from their experience at other facilities.
Thank you, Todd. Chair Connery?
So we talk about industry standards, and obviously they're entirely voluntary unless a regulator decides that it's not voluntary. So DOE would have to invoke it as a requirement for its nuclear facilities. Given that fact, can you just kind of tell us what's the state of adoption of the standard at this point in time?
I'm not familiar with some of the Department of Energy discussions on how they might incorporate that at the site. That could be site specific. It may not apply to all of the facilities, depending on what programs they already have in place. I can tell you that not only was it used at commercial nuclear reactors, but Dr. Grossi mentioned all of the test reactors, and again, that's a reactor. Some have neutrons, right? But again, all of the locations outside of the reactor would apply the same degradation mechanisms. And I had the opportunity to work on a standard with the International Atomic Energy Agency a few years ago for all of their test reactors, the same kind of process.
So moving forward, do you see this being more widely adopted in other non-reactor facilities?
Yeah, I do. It's a very straightforward process based on sound engineering principles and data, 30 and 40 years of operating history as well.
So how are you promulgating it? Are you going out and talking about it, or presenting obviously at the IAEA and other places, or is it more people come to you and say, hey, got a standard I could use?
Yeah, so I mean, as a standard design organization, they're nonprofit, or I mean, they make profit so that they can exist, right? So from a standards development standpoint, you do want the standard to be implemented because it's a revenue generator as for the standards design organizations. But we're not very prolific out there saying, hey, you need to put this in place. So it's mostly, a kind of a word of mouth or presentations. Like I've done a few recently on it as well.
Get your own YouTube channel yet?
I don't have social media.
Well, you're going to be on social media now,
There we
because just to let you know, we do record these and put them up for public consumption later on. So we want to make sure that we have a chance to dialogue with kind of all of the morning sessions, so that we're going to transition into that right now. And I'll start and then turn it over to Mr. Summers. And for the audience, this is kind of our last session before lunch, but this is the fun part, the give and take. And if you guys have questions that you want to ask each other, feel free to jump in at that point in time, because we want to make sure we get the most out of the dialogue. So GAO and ANS have different roles, but you both got to think deeply about what constitutes effective regulation of hazardous and complex activities. Different models of regulation are used across government and industry. In some cases, all the requirements governing a specific topic, like aging infrastructure management, are located in a central regulation or directive. In other cases, relevant requirements may be distributed across many different sources. DOE's current regulatory framework for aging infrastructure management uses this type of distributive requirements model. So I'm going to ask you to kind of think in the theoretical versus the actual. So based on your experiences, how do you view the relative merits of centralized versus distributed requirements? And are there any attributes that are vital to making distributed regulatory models successful? So it's a softball.
I'll start here. Yes. So many things about how DOE operates are distributed. So that's a theme in the work that we see. I think, the variety of facilities that are operated across the nuclear security enterprise are sort of staggering. And the number of different requirements to keep track of is very difficult. I think one of the key challenges here in making something distributed like that work is the model that you put in place for the contractor accountability. Because in DOE, everything is sort of contractor managed and operated. So we have seen in the past, this goes back a long ways, where sometimes, key directives or orders were missing from a contract or a contractor requirement document that sort of makes an order or a directive binding on that contractor could have been improved, or just sometimes when the contract oversight or management mechanisms haven't necessarily been in place to emphasize certain types of operational conduct, or to ensure that maintenance or aging management is prioritized in the way that the contract is managed, or that award fee is determined. So a lot of this for us always comes down to how is the contractor being overseen and managed to incentivize the behaviors that result in the optimal outcomes for the site. And infrastructure management is absolutely a priority with respect to that. And so from my perspective, coming back to your original question, central or decentralized, either way, it really comes down to, for us, how is that operationalized in the contract oversight model?
Because I completely agree with everything that Allison just said. So my comma and here too is, does EM have the workforce, the right number of people with the right knowledge, skills, and abilities to actually execute that function as well? Because the money is not slowing down in terms of its expenditure, even if there are some critical shortages. And so what is being missed by having a 27% vacancy rate with nuclear engineers? What is being missed by not having, facility reps at a particular site? And so kind of underscoring your original question, I would say, where are the major gaps in the workforce? We've got a report out, issued last month that kind of isolate that, and it's publicly available, but basically shows here's where vulnerabilities exist because we don't have the right number of people with the right knowledge, skills, and abilities to fulfill the function.
So Todd, did you have a comment on that, like distributed versus centralized, in terms of where that type of standard should be located?
So I see, I guess I have maybe a different vision on central versus spread across, but I think that you can apply a regulation across the whole complex, looking at a standard on how to implement that. And then what I see success in the commercial nuclear side is the sharing of that information. And I know the facilities have already started working together and communicating, participating in workshops on aging management and trying to disseminate how it's best to implement those requirements and make it more of a strategic combination of all of the facilities. I think the commercial nuclear industry has shown that you can have a much more effective implementation and achievement of the objectives that a standard or a regulation provides.
Thank you. Mr. Summers?
Thank you, Chair Connery. So my topic I'd like to switch to is talking about standards, or continuing talk about standards, and specifically about industry consensus standards. So GAO informed its leading practices relating to aging infrastructure management with the ISO 55000, which was mentioned earlier, consensus standards, and the American Nuclear Society is a major producer of industry consensus standards. So my first question is, how do you view the role of industry consensus standards in driving improvements to safety and informing essential federal regulations?
Well, I'll start off. From our point of view, they're essential for considering. The standards are there for a reason. They're consensus standards. There's been a lot of stakeholders involved in the development, a lot of ideas to come down to those standards. So absolutely important for consideration and benchmarking what you're doing. Even if your particular organization, the full standard may not apply, it's still worth reviewing and seeing what may be useful for your particular circumstance.
Yeah, and DOE is interesting in that, as you've mentioned, it has lots of its own standards, and then there are industry standards that are also out there that sometimes are referenced in DOE standards, sometimes are not. This is something that DOE has grappled with, and we've looked at in other contexts as well. There is something out there called the Kansas City model, which is for non-nuclear standards, but looking at sort of why are there all these DOE-specific standards for non-nuclear component production when industry standards are well understood and might be less burdensome. And so there had been some attention paid on the non-nuclear side, particularly with respect to operations at Kansas City, that could be instructive in thinking about how industry standards versus DOE's own standards are adopted. There have been looks over time at whether DOE standards create more burden and do or don't necessarily relate to a higher safety standard or a higher production standard. It's been some time since I understand anybody's sort of revisited that, but that could be, a beneficial look going forward is sort of what are there meaningful differences between the DOE standards and the industry standards?
And I'll just riff off what my colleagues mentioned just now and say that I think that industry consensus standards have a role in a little bit of a perhaps atypical way, or benefit in an atypical way too, in that EM in particular has long suffered from a trust deficit, going back to its origins. There's been mistrust by the public for sometimes earned reasons, even though perhaps it was decades ago in certain cases, and having industry consensus standards, I think sometimes can provide a little bit of a layer there of trust that can help for EM.
Yes, yes, and yes. How's that? And really, if there's, as an industry, any industry, if you find a need for a standard that could fill a gap, especially like with a new technology, even A&S, we're looking at AI standards, and some of those are going to be hard to tackle, right? But any industry, especially a longstanding industry, if there's a gap, that's what a standards organization can do. You put the working group together and you start closing that gap. And then it goes back to the OMB A119 circular I mentioned, that the federal agencies also need to participate. I mean, it's an expectation to help ensure that it's going to be a product that because a federal agency would rather have a consensus standard than trying to put their own regulation into place. It'd be easier to say, this is a standard that meets our requirements, these are the requirements we want. And then there was one point that I already forgot that I was going to bring up for you, so I guess I'll have to remember that in a second.
We'll give you a little bit of time.
Thank you. As a follow-up, and Todd, you just mentioned as far as the potentially new types of standards like AI and what the impacts are of AI. Are there any areas where each of you think that there are new or expanded industry consensus standard coverage that would be particularly beneficial to the enterprise?
This is an answer, but not exactly to your question. It would benefit EM greatly to have optimization models in place, and I know that's not exactly what you're getting at with your question, but it does go back to something my colleague Dave Maroney talked about in terms of leading practices, and I think that for EM anyway, at the very foundation, it came into being with a bunch of stovepiped agreements rather than having an optimization model driving its decisions. And I think at the end of the day, even upstream of most things, having an optimization model that at least transparently put out what is the smartest way of reaching the finish line is very helpful.
One of the things that we're starting to see happen, and I think this is beneficial, it's not quite a standard, but it is standardization, is there was some discussion earlier about infrastructure that is maybe lower risk. So balance of plant sorts of things, office space. To a certain extent, things like fire stations that are critical to a site's operation aren't in and of themselves nuclear facilities and often need replacement and are essential to just a site's operation. One of the things we're starting to see is a move towards standardized construction of those types of facilities that can really aid in quicker construction, reduce costs for design. And so there are, I think, those kinds of opportunities to think about reconceptualizing the sites where they have shared standard infrastructure that can maybe take the burden off of some of these quite hazardous type projects and allow sites to focus on those areas that are unique.
I'm just curious if there are any industry standards regarding lithium-ion batteries used in vehicles that are operating at some of the sites that you oversee.
Well, I don't oversee any sites, but and I know at the Idaho National Lab, we do a lot of research in that area, and I'm not familiar with whether there is a standard or not, maybe from the IEEE folks, but this is a case that if there is a need for a standard, that we could utilize the research that's gone on in that area and the folks who developed some of those lithium-ion batteries and come together for a standard in managing how to ensure you're doing the right condition monitoring, et cetera.
Thank you very much. Chair Connery?
So we want to talk about the Y12 approach to risk prioritization of aging management, and not just because we have folks from from Y12 here today, but obviously that's one of the sites where this has pinched the most, I guess, is the way I would put it. So ANS 314 contains an appendix for informational purposes that you were mentioning earlier that addresses risk prioritization of aging management and life extension activities. This appendix was adapted from material provided by CNS, Consolidated Nuclear Solutions, LLC, which is the management and operating contractor for the Y12 complex. This topic intersects with work that I think both of you have done, both ANS has done and both GAO has done. So I'm going to start with Mr. Anselmi. Could you describe the key attributes of Appendix B on risk prioritization of aging management and life extension activities?
Well, I do have a copy of it right here. I can read out of it. No, the basis for that appendix, I'm going to kind of veer off a little bit because I remember Mr. Maroney bringing up something on, data assets on the criticality. So if we have a facility that's done a good job of identifying, well, what are the critical components, not just from safety, but from, mission success, then once you take those and you have limited amount of funds that are competing for all of the funding, the projects are competing for the funding. So that appendix is intended to look at, well, what is the function that the equipment provides and helps prioritize, and I don't recall the details in that appendix specifically, but then how do you apply the funding to the specific projects that require funding over time? And it's something similar I've done at my facility. I know it's a reactor facility at the Advanced Test Reactor, but I haven't quite utilized that appendix, but it's a very similar approach where you look at the risk and the criticality of the equipment and say this requires funding because we think it's got closer to failure.
Thank you. I have a little bit of an introduction, then there's questions for Ms. Bowden. Years ago, the Y-12 site found itself in a very difficult situation when two older nuclear facilities were suddenly required to continue operating much longer than anticipated due to problems with a major facility modernization project. In the absence of clear requirements governing the proper response to these circumstances, Y-12 created a new management approach that it called the Extended Life Program. Y-12 then applied the new program to the two affected defense nuclear facilities. In a letter from 2017 to the National Nuclear Security Administration, the board noted that the Y-12 Extended Life Program included many positive aspects that may be worth replicating at other DOE sites. So, Allison, ma'am, could you share GAO's perspective on Y-12's handling of facility life extension needs prompted by challenges specifically with the uranium processing facility project?
Yes, and we actually have ongoing work on this project right now, so I'll try to steer clear of any preliminary observations on that. But the Extended Life Program is a very good outline for sort of making transparent the level of work that will be needed in specific facilities where basically scope from the original uranium processing facility project was removed in order to manage the overall cost and schedule of that project and necessitated maintaining older facilities for longer in order to keep certain capabilities available, either that were already in those facilities or that would be moved into those facilities since they weren't going to be considered in the overall scope of the replacement project. And so doing that had a very defined scope, both in terms of what would be needed to maintain, to invest in those facilities, to have them endure for much longer than was expected, as well as to modernize or move capabilities into those facilities. Essentially, it had, or has, it's still ongoing, a very clear budget, a very clear scope. It's well tracked, and something that we've pointed to as a particularly transparent model for how to accomplish this. The project is currently facing a new raft of challenges. The UPF project itself, it is now running pretty significantly over schedule and over budget, which will necessitate keeping 9212, which is the facility that the main process building is intended to replace, operating for longer than anticipated. And that's a facility that is in particularly poor condition, and will need to, it needs to be similarly understood how to maintain that until the UPF construction is complete. There are activities ongoing there to think about that work, but the extended life model is one that could be very helpful for thinking about 9212 now, and helpful in other places in the complex, especially where we've seen proposed construction projects deferred or paused to replace other capabilities, or to think about how to right-size facilities and make use of adjacent infrastructure for longer than intended.
Chair Connery?
Well, I want to thank our panelists this morning, Mr. Maroney, Ms. Bodwin, Mr. Anderson, Mr. Anselmi, for your participation in this hearing and your willingness to share your expertise and unique perspectives. I think we've heard a lot this morning. I can't synthesize it all. I think the importance and value of consensus standards, in so much as you have a lot of stakeholders engaged with a broad range of experience, can provide standards that are adaptable to different experiences. The note that contractor accountability is probably as important, if not more important, than whether it's a centralized or distributed standards system. We heard loud and clearly that an optimization model for EM would be something that you all think is a good idea, and then the overarching concern with, are there personnel available to oversee these activities as we move forward, because the personnel are aging as well as the facilities, but there's just not enough of them to do the work that you guys have outlined. So I really appreciate all of the inputs that you guys have given us. We're going to be kind of cogitating over them for a next little while, and I'm sure that my staff has you guys on speed dial, and will continue to reach out to you. So at this time, we're going to take a lunch break. We're going to come back at 1 o'clock. There's a 2-hour time period, so you should have plenty of time to nourish yourself, enjoy the sunshine, and all that Washington has to offer. If you're not familiar with the area, there is a handout that summarizes convenient lunch options on the table out there by the elevators. And like I said, we're going to reconvene here at 1 o'clock. To have a session in the afternoon with our afternoon panelists. So again, thanks everybody for coming, and we're going to suspend the hearing at this time until we reconvene at 1. So thank you. Welcome back, everybody. I'm going to call us back for our afternoon session. And I'd like to introduce our second panelists and our second panel panelists and invite them to be seated. In this session, we are going to hear from the Nuclear Regulatory Commission, or as we know them, the NRC. The NRC is recognized as a worldwide leader in regulation of nuclear power reactors as well as non-reactor nuclear fuel cycle facilities. This afternoon, we'll also hear from the U.S. Army Corps of Engineers. The Corps of Engineers manages a broad array of United States critical infrastructure. And finally, we'll hear from the National Aeronautics and Space Administration, as you know, NASA. Like DOE, NASA is responsible for safely managing a diverse complex of strategic infrastructure in service of an important national mission. At this time, I'm going to introduce our second panel and invite our panelists to be seated. Mr. Brian Smith is the Director of the Division of New and Renewed Licensing at NRC. Mr. Smith's current role is focused on licensing new and existing nuclear reactors, and he was previously the branch chief in the Division of Fuel Cycle, Safeguards, and Environmental Review. Mr. Smith is uniquely qualified to discuss the aging management approaches at both nuclear reactors and non-nuclear facilities that the NRC regulates. Mr. Peter Dodgen is the branch chief for asset management in the Civil Works Division of the U.S. Army Corps of Engineers. The Army Corps of Engineers Division of Civil Works is involved in developing and managing the nation's water resources. This includes designing and constructing harbors, waterways, dams, and reservoirs. Mr. Dodgen's organization plays a crucial role in maintaining and optimizing water resources infrastructure for the benefit of the public and the environment. Dr. Joel Carney is the Assistant Administrator of Strategic Infrastructure at NASA. Dr. Carney's office focuses on NASA's infrastructure challenges, working with mission directorates and NASA centers to ensure mission-critical assets are safe, ready, and reliable. Dr. Carney manages more than 5,000 facilities and assets in NASA's portfolio while constantly looking for opportunities to consolidate and revitalize NASA's infrastructure. Dr. Eric Weiser is the Director of Facilities and Real Estate Division within the Office of Strategic Infrastructure at NASA. Dr. Weiser's team provides functional leadership for all NASA facility engineering programs, including master planning, facility planning, design, construction, operation, maintenance, and real estate management. His team also provides consulting and analysis tools to support decision-making about NASA's real estate and infrastructure. We welcome all of our afternoon panelists and thank you for sharing your expertise and insights. Like the morning panel, we're going to give you each organization a chance to provide opening remarks, followed by a question and answer for that organization, and then finally an open session for the entire panel. So if you guys would like to come up and take a seat behind your placards. So this is a similar structure to what we did this morning. And I'm going to invite Mr. Smith to start with his opening statement as soon as he's ready.
There we go. That's the right button. All right. Chair Connery and Vice Chair Summers, thank you very much for inviting me today. I'm excited to be here. Look forward to the presentation and the questions and answers. So my name is Brian Smith, Director of Division New and Renew Licenses at the NRC. I'm here to talk to you about our approach to aging management for nuclear fuel cycle facilities and power reactors. When I say fuel cycle facilities, what I mean by that are those facilities that are involved in the process for producing the fuel for the commercial power reactors as well as for the Navy, but not including the uranium mining and milling. So uranium conversion, enrichment, fabrication. So next slide, please. The regulatory frameworks for fuel cycle facilities and power reactors differ with respect to how aging management expectations are defined. The regulations for fuel cycle facilities are performance-based and do not specifically identify the need for aging management. However, it is implicitly addressed through the required management measures. These licensee-defined measures ensure that items relied on for safety, or IROFs, are available and reliable on an ongoing basis, including during license extension or what we call license renewal. In contrast, the reactor regulations generally provide much greater explicit expectations for the management of age-related degradation issues. Several regulations address component maintenance and other management activities throughout the entire plant life, while license renewal requires an additional layer of aging management. In both approaches, NRC inspection oversight collects information about licensee performance and ensures that licensees appropriately respond to aging issues to maintain safe operation. Next slide. The Licensee's Safety Program and Integrated Safety Analysis, or ISA, identify and demonstrate how the risk from high and intermediate consequence events are appropriately minimized. These events are specific to each facility and determined by conducting a hazards analysis using various techniques to identify accident sequences. Examples of accident sequences may include a radiological release due to a detonation of a hydrogen gas leak, a gaseous release of uranium hexafluoride, or a nuclear criticality. Once these accident sequences are identified, their consequences and likelihoods are determined and are then compared against what we call the performance requirements. These are radiological and chemical exposure thresholds for workers as well as the public for high and intermediate consequence events, as well as the qualitative and quantitative likelihoods of the accident sequences themselves. IROS, which include components, equipment, and licensee activities, are then identified to prevent or mitigate the consequences of the accident sequences. Management measures ensure those IROS remain available and reliable. Next slide, please. Fuel cycle facilities follow a consistent aging management framework throughout the entire facility life, including license renewal periods.
As discussed in the prior slide, this includes IROFs and associated management measures to minimize accident risk. The ISA, management measures, and the overarching facility safety program are established at the beginning of operation and continue to be updated throughout the facility life. The ISA summary is maintained as a living document and submitted to the NRC for review. Thus, aging issues are addressed by developing and maintaining the ISA and ensuring that IROFs are appropriately available and reliable on a continuous basis. When field facilities go through license renewal, aging-related issues are not specifically addressed, as the ISA would continue to be maintained. Next slide. Management measures are required to be applied to fuel cycle facility IROFs in a manner commensurate with the item's contribution to risk reduction. These measures include preventive maintenance, personnel training, inspection procedures, incident investigations, and application of quality assurance elements to IROFs. General expectations are provided in NRC guidance. However, the applicants and licensees propose the specific details for NRC review and approval. The NRC's licensing reviews and oversight program verifies their effectiveness. Next slide, please. The NRC's fuel cycle facility inspection program comprises core periodic inspections and as-needed inspections for certain activities or events to verify that the licensee is safely operating its facility. Inspectors focus their attention on activities important to safety using a risk-informed, performance-based approach. NRC inspections cover such issues as configuration management and change control programs, determination of risk significance of events and degraded conditions, maintenance of IROFs, and assessment of equipment conditions that may degrade plant performance. Next slide, please. So now moving on from fuel cycle facilities to power reactors, the systems, structures, and components, or SSCs, of interest for aging management are first defined by whether they are safety related or if their failure could affect a safety related component. This is determined by whether the SSC fulfills one of the noted safety functions. And these are to maintain the integrity of the reactor coolant pressure boundary, the capability to shut down the reactor and maintain it in a safe shutdown condition, and prevent or mitigate the consequences of accidents with potential off-site exposure. As I'll explain shortly, renewal aging management activities focus on a specific subset of these safety-related SSCs, those that are passive and long-lived. Additionally, aging management is performed for certain non-safety related SSCs for issues of heightened importance. These are associated with 5 regulations that address fire protection, environmental qualification of equipment to ensure it can perform under accident conditions, pressurized thermal shock of the reactor pressure vessel, reduction of risk that the reactor shutdown or the SCRAM system fails during an accident, and station blackout or loss of off-site power. Next slide, please. Similar to the fuel cycle facility framework, reactor licensees are required to meet several regulations to account for materials degradation throughout the entire plant life. Many regulations are broadly applicable, such as the requirements to maintain a quality assurance program, the maintenance rule to monitor component condition, and the use of codes and standards that govern inspections and testing. Some regulations are targeted to a specific degradation topic, such as monitoring the radiation embrittlement of the reactor pressure vessel. License renewal extends the original 40-year license in additional 20-year increments, and it includes additional requirements. First, aging-related calculations from the original license, or time-limited aging analyses, need to be reevaluated to account for the longer plant life. An example of this would be an assessment of the additional mechanical loading cycles for metal fatigue. Second, additional aging management inspections and other activities are applied to components that may have received less attention earlier in plant life as they were considered inherently reliable. This applies to passive long-lived components like a pipe wall or water storage tank that are not periodically replaced. Next slide, please. The generic Aging Lessons Learned Report, or GAL report, like we heard about this morning, supports predictable and consistent NRC licensing reviews by identifying one acceptable approach to managing aging. However, applicants for renewal can always propose an alternative. The GAL report identifies aging effects that must be managed, such as cracking or corrosion, based on a component's material of construction and service conditions, and defines aging management programs to monitor or inspect for those issues. An example is the Gall Reports program for buried piping, which includes both preventive measures and periodic inspections to ensure that corrosion and other aging effects will not challenge the pipe's safety function and extended operation. The Gall Report was developed with input from the industry and other stakeholders. Next slide, please. The License Renewal Inspection Program verifies that licensees are effectively implementing their approved aging management programs. NRC inspectors review plant documentation and interview site personnel to ensure that inspections are being completed, operating experience is evaluated and used to enhance plant programs, and corrective actions are appropriately taken when degradation is found. The Renewal Inspection Program is a complement to the NRC's baseline inspections that cover the entirety of plant life. The baseline inspection program includes oversight of many of the regulated activities shown on an earlier slide, such as quality assurance, maintenance effectiveness, and implementation of the ASME Code in-service inspection program. Next slide, please. The NRC's renewal inspection procedure requires periodic inspection of licensee aging management activities. These inspections occur just prior to and throughout the periods of extended operation. This graphic shows the NRC inspections that occurred during the initial 40 to 60 year renewal period and subsequent 60 to 80 year period of extended operation. The inspections prior to the periods of extended operation ensure approved aging management programs are in place and any early inspection commitments are being fulfilled. The inspections during extended operation continue to verify that the aging management programs are being effectively implemented and enhanced as appropriate based on operating experience and inspection findings. Next slide. The NRC actively monitors and assesses operating experience from several sources, such as from NRC resident and regional inspectors, industry-wide operating experience clearinghouses, and technical exchanges with the industry and international counterparts. The NRC reviews operating experience to determine the safety significance and assess the need for follow-up actions by the NRC and licensee. These may include plant-specific actions, such as augmented inspections, communications to the wider industry, and NRC oversight of plant response. Operating experience may also lead to updates to the NRC regulatory framework. For example, work within the ASME Code committees or update the NRC Gall report to enhance inspections in a particular area. Next slide, please. As facilities age, finding suitable replacement parts can pose challenges to operators. However, the NRC does not regulate such operational issues. The licensees are responsible for safely maintaining parts in accordance with their license, including ensuring component safety functions are maintained. The U.S. industry uses collaborative resources like the Nuclear Utility Obsolescence Group to help plants identify potential obsolete items and identify replacement parts and other solutions. While the NRC does not explicitly regulate obsolescence, the NRC maintains an oversight role in potential obsolescence solutions. For example, inspection of plant quality assurance programs to ensure the suitability of replacement parts. Next slide, please. So in Todd's presentation, he talked about the requirement for government agencies to participate in standards organizations and in the development of the codes and standards. The National Technology Transfer and Advancement Act of 1995 requires that regulatory agencies participate in the development and use of technical standards that are created by voluntary consensus standards bodies to the extent practical. So not just participate in the code development, but also utilize those in our regulatory frameworks. So we actively participate in the development of many standards that address aging issues, and we rely on these standards, citing their use in our regulations and guidance. When a consensus standard is not available or it does not fully address an aging issue, the NRC creates its own guidance. The Gall Report aging management programs are often a mix of consensus standards and NRC-specific guidance. Next slide, please. The NRC frequently engages with international regulators and facility operators to share experiences and document best practices to support long-term operation. We hold leadership roles in the International Atomic Energy Agency IGAL program, which Director Grossi talked about in his presentation this morning. We also support the Nuclear Energy Agency Working Group on Integrity and Aging of Components and Structures. These and similar groups share knowledge and develop guidelines to assist organizations around the world in their preparation for extended operations. As you can see from the photo from last summer, we hosted a workshop with approximately 30 representatives from 5 countries and the IAEA to share U.S. experiences and exchange insights on long-term operation and regulatory reviews. So regulators from around the world. So next slide, please. So this concludes my presentation. I appreciate the opportunity to present and welcome any questions that you may have. Get some water.
Thank you for that presentation. It was very informative, and I appreciate the callbacks to some of the panelists in the morning so we can understand it in the context of the other information that we received. So, as you noted, some of your remarks, as well as the comments we heard from the IAEA Director General Grossi, demonstrate that the power community has a robust aging management program backed by fundamental science and engineering. Would you highlight any elements from the NRC's aging management review process for power reactors that, in your professional experience, the board, the DNFSB, should examine to potentially enhance safety at the DOE's defense nuclear facilities?
Okay. So when we do a license renewal review, one of the most important aspects of it that we do is looking at the site-specific operational experience, primarily to evaluate the adequacy of their proposed aging management programs. A lot of times, most every time, they utilize our guidance in the development of their aging management programs. Sometimes those aren't a one-size-fits-all. There may be site-specific aspects that would require the aging management program to be enhanced to address those issues. So that's one of the things we recommend is looking at site-specific issues. Also, if you are going to be developing guidance, we'd recommend that you involve a lot of the stakeholders to be able to do that. We went through a long process in the development of the original GAL guidance and then the update of the guidance to address subsequent license renewal. So working together to be able to come up with proposed guidance or programs. And in our guidance, like I mentioned earlier, we do utilize a lot of the codes and standards. The slide that I had that showed the various organizations, all of those are referenced in our GAL guidance document. So utilizing a lot of different codes and standards, supplementing where necessary. Finally, inspection would be an important part of any future program as well, to ensure not only that the aging management programs are being implemented, but that if they do identify aging issues, that they fully address those and enhance their aging management programs as necessary.
Thank you. Mr. Summers?
Thanks, Chair Connery, and thank you, Brian. I'd now like to ask and talk a little bit about aging management of active and passive structures, systems, and components. Safe operation of reactors and fuel cycle facilities rely on a combination of active and passive structures, systems, and components. Active and passive safety controls obviously have different failure rates and different aging mechanisms. So my question is, as facilities progress through their life cycles, how does the NRC's regulatory approach handle aging management for active and passive systems in fuel cycle facilities?
Okay. As I mentioned in my presentation, the licensees are required to perform to conduct an integrated safety assessment, integrated safety analysis, ISA. And in doing that, they have to identify the various accident sequences to ensure that the performance requirements are met, to ensure that high consequence events are highly unlikely and intermediate consequences are unlikely. So two kind of qualitative terms there that the licensees actually define in their methodology to us. And so when they initially do their ISA, they have to come up with reliabilities of their IROFs, their items relied on for safety, to ensure that those accident sequences remain unlikely or highly unlikely throughout the life of the plant. And so that's where the management measures come into play. Preventive maintenance, corrective maintenance, testing, surveillances, all of the typical things that you would expect in a program like that, quality assurance. for both active and passive components in a fuel cycle facility.
Very good. Thank you, Brian. Now I'd like to talk a little bit about detection and monitoring and have a couple of questions on that topic. In your statement, you indicated that the NRC regulations expect items relied on for safety to be available and reliable to perform their safety function. DOE expects the same from its credited safety systems. So my first question is, one of the best practices that our board staff here has encountered in this regard is a site that performs complete failure modes and effects analysis of a safety system. Would you please comment on benefits of this practice from your experience across the NRC?
Okay. Failure modes and effect analysis is one methodology that we recommend for our licensees to follow when they're conducting their ISA. We have a guidance document called NUREG 1513, which is our ISA guidance document. I think that's the actual title of it. And in there, it mentions a number of different methodologies and techniques, failure mode and effects analysis being one of them. HAZOP, what if, checklists, even fault trees, like if you want to do like a PRA type thing, actually doing fault trees. So depending upon the complexity of the system or the accident sequences involved, the licensee may use one or a combination of the different techniques in evaluating their facility.
Thank you. My second question is, another best practice that our board staff has observed is a site that adjusted its frequency for surveillance and monitoring of an aging safety system after observing an increased rate of degraded performance. So my question is, would you describe how the NRC would treat such a situation?
Well, our licensees obviously would address that situation, and we would probably would expect them to do something very similar. Either change their inspection frequency to verify the reliability, availability of the IROFs, or they could repair, refurbish, or replace the IROFs itself. In a fuel cycle facility like these, changing out IROFs or addressing IROFs like this is a little bit easier than, like, say, a power reactor, where you have much lower radiation dose fields and such, where you can do things like that. As I said earlier, they have to satisfy their performance requirements throughout the life. So those accident sequences have to remain either unlikely or highly unlikely through the maintenance of the IROFs.
Thank you. Chair Connery?
So I appreciate it, and I just want to, recognize the fact that the analogy between the NRC and DOE is a perfect analogy, because you're an outside regulator. Obviously, DOE is self-regulating, and they have us for oversight, which I'm sure they love. But I want to talk a little bit about technical obsolescence, because I thought it was interesting that you stated that NRC doesn't regulate obsolescence, that there is a nuclear utility obsolescence working group.
Yes.
And sure, there's an acronym for that, but I haven't figured that out yet. But they are subject to the regulations and requirements of the NRC to include quality control on replacement items that they might use in case of obsolescence.
Yes.
So my first question is, on the timing of that? How do you figure out the timing that something is going to be becoming obsolete? You're going to have to replace that. You potentially have to replace that in more than one plant, but you also have to have the quality assurance for the replacement. So what's the conversation between you and the licensee to make sure that any replacement item or component is appropriately QA'd by you all before it's implemented?
Okay. The licensees have to maintain, they have to meet their licensing basis going forward. And so if a component needs to be replaced and is maybe considered to be obsolete, they have to replace that safety component with something very similar, or if it's something a little bit different, then they have to follow our change process, our facility change process, 5059 process in our regulations, to determine whether or not that's something that would require NRC approval or not. How significant is the change? Does it increase the risk in the overall facility? And if it does, then it would have to come into us for review and approval first. But essentially, those those decisions are made by the licensees themselves.
So they have to be pretty on top of things that are degrading in order to know that they would become obsolete in a particular time frame.
Yes.
So both power reactors under your purview and new DOE, DNF, Defense Nuclear Facilities overseen by us, share a particular trait in that they take a while to construct, and maybe more than a while these days, sometimes more than a decade. Because there are often advances in technology in the time between facility design and eventual completion, it's inevitable that these construction projects are faced with technical obsolescence. In safety systems in particular that have been designed or installed but aren't yet operating. So can you share any insight that the NRC has developed to address this problem in particular?
Sure. So we have two different licensing pathways for power reactors in our regulations. The Part 50 process, the original construction permit operating license pathway, and the relatively newer process in Part 52, which is the combined license process, where you have like standardized approved designs such that you can reference those in a combined license application in the future to try to make the licensing process a little more efficient. The Vogtle process, the Vogtle plant followed the Part 52 process, but all the plants prior to that followed the construction permit operating license phase. So actually the newer plants that are going through the licensing process now are following the older process, the construction permit operating license. We have a construction permit application in-house now for TerraPower's Wyoming facility. And we recently approved Kairos construction permit for a test reactor in Tennessee. But in the older process, in the construction permit applications, it's more of a preliminary design, which we review and approve for them to allow them to start construction. And then during construction, they'll submit an operating license application, and that is supposed to represent the as-built plant. And so as we're reviewing it and as they're finishing construction, they can make changes to the application to reflect that as-built plant. Ultimately what we approve and issue the operating license is consistent with the plant that's built. For the Part 52 process, the design is typically approved in advance, and there's a design cert issue or standard design approval that's been issued. So when you review the COL license application, it's primarily just site-specific aspects, operational programs that you're looking at. You can't start construction until you actually get issued that license. So there's pros and cons for either way you want to go there, but that's the way the Vogtle went. And so during the Vogtle construction, there were a number of different changes that they identified, whether it was obsolescence or just optimizations in the construction that they wanted to do, that required a number of different license amendments that had to be applied to us for approval. I think it was around 200 actually during that extended construction period time. So that's how we can address it during construction. Even if there is some new technology out there that may be better for a certain aspect of a plant, doesn't necessarily mean that we'll require them to implement that. Once we've approved a license, that's their licensing basis going forward. If there's a safety reason to where we would consider requiring them to upgrade to a certain new technology, we would have to follow our backfit process before we followed through with the ordering of them to implement those safety measures. And the backfit process is kind of like a cost-benefit review that we do. Does it balance out with adequate protection of public health and safety or not? A licensee may choose to make a change, or they may be constructing and realize that we can't do it that way, and we want to do something different, and they have to follow that change process and come to us for an amendment if it requires it.
Understood. Thank you. I appreciate that. So I'd like to thank you for sharing your expertise, and I'm going to turn the microphone over to, well, actually, you have your own microphone, but to Mr. Peter Dodgen from the Army Corps of Engineers to provide some remarks.
Thank you. Good afternoon, members of the board and colleagues present. I'd like to give a brief opening comments describing the U.S. Army Corps of Engineers Civil Works Infrastructure portfolio. After that, I'll describe some topics about aging infrastructure. Specifically, I'll introduce the Army Corps' infrastructure monitoring practices and how we use risk management techniques to prioritize investments. Next slide. So first, let me clear the air about the Army Corps of Engineers Civil Works portfolio. The U.S. Army Corps is a complex organization with elements operating in uniform and in conjunction with regular Army units to provide combat engineer capabilities and combat units to combat units in the Army. The U.S. Army Corps also has significant human assets engaged in delivering engineering and facility services to the Department of Defense, again, to the combat and sustainment side of the Army and the U.S. military. The Army Corps of Engineers Civil Works, however, plans and designs, builds, and most significantly operates and maintains civilian infrastructure across the nation. This infrastructure serves civilian purposes and is operated and maintained by civilians for public benefit. And then the nexus with national defense purposes is indirect for these assets. I mentioned this in order to kind of clear the context for the testimony I'm going to offer today. Next slide, please. Again, for context about the infrastructure I'm speaking about in the U.S. Army Corps Civil Works, it's worth noting that we manage large concrete, earthen, and dam and levee infrastructure, hydraulic steel structures, or gates, electric generating, and operating equipment across the nation. The portfolio comes in the hundreds of units, so we operate portfolios of these assets, and each one is a little different due to site conditions and the purposes for which each facility was designed to serve. Of note, our work managing harbors and channels occupies an outsized portion of the Army Corps footprint in terms of our total investment annually. However, I will be focusing my remarks on the vertical infrastructure to better address the board's interests. Next slide, please. One last slide about the Civil Works context. Many observers don't notice, but the Army Corps is the leading provider of recreation in terms of visitation across the country. So we manage significant recreation assets. Another silent but significant infrastructure class in our Civil Works portfolio is roads and bridges. And many of these bridges are used to provide a facility access for us, but some of them are also public bridges as well. Next slide. Okay, now I'm going to address the board's particular interests in infrastructure. I'm going to begin with infrastructure monitoring. I want to make an important point about infrastructure monitoring. Many analysts will focus their attention on the strategic asset monitoring techniques because they're conspicuous. They require specialized kind of expertise and dedicated resource. But as the board considers methods to monitor condition, please keep in mind the effect and dexterity of our tactical monitoring systems. Most facilities have maintenance and operations staff that are on site routinely. These personnel know the condition of the facility and detect meaningful changes in condition and are integral to any strategic monitoring system. This capability can only be realized or exploited when the organization recognizes the value of this tactical aspect and establishes procedures and systems to capture the information for portfolio level use. Next slide. There are many ways to begin the conversation about the strategic monitoring of infrastructure, and I will highlight some of the prime time aspects of our system in the Army Corps. First, as I mentioned, we are leveraging the maintenance management practices of our staff on site. We have set out requirements for use of our computerized maintenance management system. Without some kind of enterprise requirement, the system will devolve into a local work management system only, and the portfolio management data will not be generated. So these basic functions and the intent, these are among the basic functions and intents of our computerized maintenance management system going forward. Another strategic approach is facility inspections and condition awareness systems, and I think that's what most of us concentrate on. So the Army Corps manages these at an enterprise level. Policy and guidance for condition assessments are integrated across critical assets like our hydraulic steel structures, our gates, our bridges, and our dam safety related assets. So we use a clearly articulated three-factor rating for condition. It integrates the physical condition or the appearance, sort of corrosion, things like that, the performance, and the probability of failure. And the assessment system acknowledges that there's some subjectivity and some bias, and so we have methods to address bias and to tamp down subjectivity, although you can never remove subjectivity from a condition assessment. I say never. Some systems you can remove it. And finally, a large portfolio of assets requires development of an asset registry. The asset information that we generate, it necessarily spans multiple business domains within an organization like the Corps, and I imagine yours as well, making a consistent system of asset organization necessary. So we've taken some steps to construct an asset registry, and it requires the organization to consider the various use cases for their assets up front in order to be successful. Okay, so next slide. Just again, very quickly, for introduction purposes, our operational condition assessment program. This is a strategic condition monitoring approach. It's like an inspection of sorts, but it's more of a subject matter expert evaluation of documentation related to key components, and it occurs every 5 years. And the assets and components receive a letter grade, and this is the first step in our risk assessment process. And so I included on this slide for interest the type of components that get rated, and it's fairly granular. We get down into some detail, and I'll show you in a minute how that looks. Next slide. Okay, the Corps of Engineers employs several avenues of risk analysis depending upon the type of the asset and the type of hazard associated with the asset condition. I heard we have intermediate and high consequence in your testimony, and we have a very similar binary in our risk analysis as well. One consistent theme across both domains is a paradigm of condition being a surrogate or a driver for the probability of failure, and the economic impacts or life safety being the most prevalent consequence factors in these analyses. Next slide. Within our dam safety, I want to talk about the dam safety risk management approach because I think it might be very similar to some of the hazards that you all face. For the most part, these hazards are characterized by very unlikely structural events, typically associated with the dam structure itself, with potentially catastrophic consequences. And these hazards require special attention both because they're relatively low likelihood and because of the nature of the consequences. So vigilance is required. And the U.S. Army Corps Civil Works applies special attention just in order to maintain awareness of the failure modes as well as any changes in the probability of those failure modes occurring. And this attention includes routine measures performed periodically through the life of the facility, and as well as special actions when an event or a periodic activity uncovers a concern. Next slide. When special concerns in this dam safety arena are uncovered, specific analyses are undertaken. And again, these catastrophic hazards are analyzed in terms of their failure modes. And we follow a consistent approach to analyze the failure modes across our entire portfolio so that we can compare risks across the portfolio. So the decision to act on any one of these failure modes is driven by the relationship to widely held understandings about societal acceptance of risks or tolerable risk guidelines, some of them from the nuclear industry. Next slide. Okay, so this gets back into the components. I listed the components, gives you some sort of a picture of how we analyze operational risks or hazards which affect the delivery of planned benefits or services from our facilities. These are, I think, the intermediate risk kind of hazards. And these hazards, they have a high likelihood of occurrence, relatively speaking, and the consequences are typically not catastrophic on a societal scale. In terms of the mechanics of the risk analyses, in most Army Corps facilities, we break them down into critical components which drive sort of a facility level performance or delivery of a benefit. Flood risk reduction, for example, or navigation throughput at a lock and dam. The condition or the suitability of these components is evaluated. For instance, with the condition assessment process, we'll use the data from the condition assessment process. And then this condition or the probability of failure information is routed through a system hierarchy to a facility level to sort of rate the probability of the facility performing. And then at a portfolio level, we can sort of evaluate these component level risks across our portfolio. And next slide. And so here's an illustration of that process. If you follow the arrows, condition rating crosswalks to a probability of failure and an economic consequence associated with a facility-specific failure scenarios. Each facility has different benefits, generates different benefits. Ultimately, as you see in the chart below on this slide, the risk can be ranked against competing risks at other facilities in our portfolio. And this leads to the discussion about prioritization. Next slide. So the Army Corps Civil Works has several use cases which require this facility or component level investment prioritization. This is a national view displaying the inland navigation facilities in the central United States along with the relative risk exposure that each presents. So this is above the components. This is at a facility level. We know which facilities are in jeopardy. For inland navigation, the primary hazard is the risk that this risk assessment evaluates is the economic losses associated with restrictions of navigation access to the waterway as a result of one of our facilities or the condition degradation at one of our facilities. And the last thing I want to say about this is that, one of the most compelling prioritization processes in the civil works arena involves our annual budget process. And looking 2 years out, thankfully our facilities age and degrade over years and not, weeks and months. And so we have a 2-year out budget cycle. And this kind of depicts how we bring sort of tactical level information together with strategic information and turn that into risk and make budget prioritizations, pump that in through our execution process and then continue rolling forward. And we are, to the extent that we continue these dialogues, one of the important initiatives that we're working on is to create long-term life cycle plans so that we can somewhat get out of this near-term cycle. So, subject to any questions, I think I'm within time.
Thank you, Mr. Dodgen, for your remarks. Really appreciate them. Now we'd like to ask you some questions to better understand how the Corps of Engineers manages its critical infrastructure. So I'll begin. First topic is the evaluating condition of assets. Your opening statement noted that the Army Corps of Engineers assigns condition ratings for its civil works assets using data obtained through various forms of asset monitoring. A condition assessment results in a rating that provides information on the remaining useful life, probability of failure, or the associated risk of the asset being monitored. So my first question is, since operational condition assessments form the basis of the Army Corps of Engineers' risk-based budget development, can you describe how these operational condition assessments are conducted and what types of evaluations are involved?
Yeah, so the assessments themselves are conducted by typically a team of engineers and maintenance savvy individuals. They don't have to be engineers, visiting the site. Like I say, we do 20% of our sites every year. They visit the site. They will look at the tactical data, interview and visit with the folks who operate and maintain that particular facility to get an idea of the assets and components that they're concerned about. And going through the asset registry that I mentioned that indicate all the critical pieces, components of that facility, they'll sort of go from top to bottom, looking for maintenance data or other inspection data. Engineers will sometimes visit the facility to do formal inspections of dam gates or there'll be an electrical, an evaluation of the electrical components, things like that. And dam safety, the dam safety community visits the dam on a periodic inspection routinely, and they analyze the dam for its structural, primarily it's the hazards associated with adverse structural events, the catastrophic, highly unlikely catastrophic events. But in doing that, they invariably, they will identify other issues, and they'll document those issues in their periodic reports. So this team will look at this existing data and the testimony of the operating staff and the maintenance staff. They'll look at certain assets when that's necessary. And to the extent that we have a reference for the letter, we use this letter grade, this A through completely failed rating system. If there's a reference, they'll bounce this information off of a reference and then assign a letter grade, and then from that point on, it all happens rather mathematically. There are a few assets I mentioned that there's no way to remove subjectivity for our electrical components. Obviously, I'm sure people realize that you can rate electrical components largely off of objective measurements, temperature, and various electrical parameters. But for the most part, there's some human judgment based on that literature and the testimony of people on the site.
Thank you. I appreciate your description. My second question is, do you change the evaluation techniques for the operational condition assessments based on whether a specific component is passive or active?
Help me understand what you mean by passive or active.
For instance, if you have specific sensors that are telling you or feeding you data about a specific component or infrastructure piece, that would be, I believe, considered to be active. Passive, on the other hand, would be a structure similar to maybe a piece of steel girder or some structure that you could do a visual inspection of, say, potentially, but is not actively being pinged for the evaluation information that goes into whether or not the infrastructure is aging or deteriorating in some way. Is that helpful?
Yes, most of the components, I believe most of the components that are in our operational condition assessment program would be considered active. So I'd say there probably isn't much of a difference, because I don't know that we have any components that would be classified as passive. I would like to look and see if that's true, but I think it's mostly true.
So based upon your answer then, both the active and passive essentially would be treated the same,
Yes.
as far as you understand.
Yes.
Very
Yes.
good. Okay, thank you very much. Appreciate your answer. I hope from my team that I gave a good description of your question. Chair Connery.
Yeah, you mentioned that if the dialogue continues, I'll tell you as soon as I got your slide deck, the staff was so excited by the detail of your slide deck that you will be getting calls from them. So one of the things I wanted to talk about was a specific software tool called Builder. And to the extent that you're familiar with it, the National Nuclear Security Administration uses a sustainment management program called Builder, which was developed by USACE Engineering Research and Development Center at the Army Corps. So the Department of Defense has mandated the use of Builder across all of its components, including the Army Corps of Engineers. How does the operational condition assessment process differ from other sustainment management systems like Builder? How are they different and how do they interact?
Okay, well, that's a really good question. So Builder is let's try to describe it this way. The Sustainment Management System, SMS, is a suite of data sets for specific types of facilities, okay? So Builder is specifically for buildings and building components, and it's an exquisite, I don't know how familiar, it is truly it's not something I would avoid using if you've been mandated to use it. It's an excellent system. But it is designed for buildings, okay? So one of your questions was, how does that relate to the OCA program? The OCA program could be thought of as another module in this SMS. It's not, but it could be. It could be within that sustainment management system that DoD uses, which Builder is a module in it. They also have a module for roads, and they have a module for roofs, okay? They have different modules in that sustainment management system. OCA could be a module in that sustainment management system, and it's not, but just entirely because of kind of issues related to appropriations. Okay, so the sustainment management system is for defense facilities. I was distinguishing the U.S. Army Corps of Engineers Civil Works from the U.S. Army Corps of Engineers. I didn't go into all the ways that were different, but one significant way is we are energy and water appropriated. So we have not worked out how to integrate between the OCA and the sustainment management system. But if we did, OCA would be a module in that sustainment management system because it's designed for different kinds of things. So Builder's here for buildings, doors, light switches, air conditioning units, plumbing, electrical systems in buildings, things like that. It's excellent for that. If you'd like some orientation or you'd like some inside, we can give that to you. The ERDIC, the Engineer Research Development Center, is the folks who run SMS are excellent people. They'd be happy to work with you to get you oriented. But OCA is broken into modules as well. So we have a module for flood risk, which is our dams that operate for flood risk, and that would be a module in the SMS. It is a kind of a building, I suppose, but it's so dramatically different from a typical building, that we can't use Builder. It doesn't address our issues. Our buildings are entirely concrete with some electrical conduits and then humongous hydraulic pumps. There's just not a building in the way that Builder's designed. So, and how do they function differently? The SMS suite. The ones that are in the SMS suite, Builder, Paver, Roofer, Railer, they have a number of modules. Aren't those cool? They have a benefit that we don't have in the OCA, and that is that their type of facility has a lot more consistency. So from one building to another, a 15-ton air conditioner has a similar life cycle, and they have 2,500 instances of that particular unit, and they're able to gather data and get degradation curves very quickly, and that's what makes SMS so attractive. They have wonderful degradation data. Ours, I mentioned, are sort of one-off. We might be using a 2,500 horsepower electric motor at 500 of our facilities, but only 200 of them are being used in a consistent way. You know, they're just running completely different appliances, working in a completely different environment. So our data, we don't gather the kind of data they do in SMS. So I hope that gives you some impression.
It does, and
Okay.
we will come back to you with more questions about that, because, you know, the operating environment is obviously a factor, the hazards are a factor, and for anybody watching, this is why the Army is so brilliant. They call builder because it does building. They call, it's very specific language that is easily understandable. NRC, take a note. No weird acronyms. So, over to you, sir.
Thanks, Chair Connor, and thanks. Now I'd like to talk a little bit about detecting degradations. The Army Corps of Engineers operates and maintains dam infrastructure is especially relevant to this hearing because, like defense nuclear facilities, dams provide a vital function. But they also present inherent risks that must be minimized and managed. So as discussed during your statement, performance issues with dam infrastructure are not always related to the age of the dam and can instead be more of a function of the construction problems or the geotechnical or hydraulic or hydrologic changes. So my first question, and just one, is regardless of the specificity or the specific vulnerability, how does the Corps of Engineers monitor and detect degradation or emergent changes that affect dam-related infrastructure?
Well, so in the context of the kind of the intermediate risks, I think we've been talking about that. The OCA process is the primary method that we use to monitor that on a strategic level. And of course, we have these systems where we monitor downtime of our components at a tactical level, and then they sort of pop up on a dashboard. In the realm of the high risk, which is related to dam failure type of scenarios, the fairly low likelihood but high consequence, we do have issues in our portfolio where there have been mostly at construction geotechnical situations that maybe we weren't addressed in a way that meet our current standards for risk tolerance. And so what the Corps does to kind of identify those situations and begin to categorize them, that was the slide. If you want to look back on it, there's some detail on the slide on the portfolio risk management. We have a process where periodically, every 10 years, we have a team of engineers sit down and basically brainstorm failure modes that are available at that particular facility, because each one's a little different. What failure modes are available here, and then that brainstorming is fairly free flowing. We don't restrict the identification of those failure modes, and then the team begins to dissect them and decide, well, what's the likelihood of this failure mode here, and they look for data to support that that likelihood determination, sort of on a screening level. And if certain failure modes exceed a tolerable risk in terms of the likelihood, then we do more detailed analysis. So that's not common. That we call these periodic assessments. It's not common that a periodic assessment identifies something that requires more detailed engineering analysis, but they do. They do sometimes, because we've been building dams for a century or so, and the standards are different, and they continue to evolve. As additional sort of failure modes reveal themselves. Spillway. I don't know if this isn't a dam infrastructure group, but in the last few years we've had some really interesting spillway situations nationally. Not the Corps of Engineers, but other dam owners have, and it alerts us to look at spillways a little bit differently. And so when those periodic assessments happen, that team will identify those and raise those for closer analysis.
Thank you. Chair Connery?
So you guys are taking more of a centralized approach, so you don't have the issues with like sharing operating experience, because it would, by definition, go across the whole enterprise. If you have components that you're worried about in one area, it would be known to all of the other dam operators, et cetera. Or do you have to do something specific for sharing operational experience?
Well, operationally, I was talking mainly about, in that answer, I was talking mainly about sort of these structural issues that are, it's information that's shared between engineers and our dam safety community. We have a fairly coherent dam safety community, and these assessments where we brainstorm about the failure modes, they are somewhat they're devolved out across the decentralized. They happen in our district, sort of at our district level, within watersheds. But there's a neuro system that comes to the headquarters that allows some sharing across the dam safety professionals about those kind of failure modes. As I mentioned, the spillway, in the recent past, there's been some trouble with spillway performance. Not with the Corps, but with other dams in the country. And this dam safety community sort of tracks that and carries those concerns into those periodic assessments. On the operational side, we could do better sharing between our operating facilities lessons learned. There's hundreds, 750 some FRM facilities, almost 200 locks and dams. We don't have a good, we don't have the CNU between those facilities that we should to share the operational lessons learned. So it has to be a pretty high level concern before it gets shared.
Oh, thank you for that. It's actually pretty interesting. So I actually have a question here about how you prioritize infrastructure repairs in funding constrained environments, but I think you kind of addressed that in your presentation. But a corollary to that is something that we talked about earlier in the day, and I know you weren't here for it, but it was about the puts and takes of whether or not to pursue repairs versus recapitalizing degraded infrastructure. And I was wondering if you could talk a little bit about how you make those decision trade-offs.
So when you say recapitalize, that's an interesting question, because in most of the world, recapitalization is entirely a financial decision. And if that's what you mean, we do that. So basically, when repairs reach a certain threshold, we consider that a recapitalization. And in the energy and water appropriation, there's a specific account for those kind of investments. Now, those recapitalizations compete with new things, which gets to the human issue and stakeholder issues that we face. If you mean recapitalization or rehabilitation in terms of what the work looks like, the kind of work that it looks like, we will typically repair our components. We will do small-scale repairs to our components until it's no longer economically justified. So we will weld, and we will change bearings, and we will restore structural components at a micro level until it becomes infeasible to do so. And typically, an engineer will make that call.
Thank you for your remarks and insights. I know we aren't a dam community, but we are very interested in your insights, because I do think that there are lessons that we can learn and hopefully that we can share across, and for your insights on Builder. So I know my staff will be coming back to you with more detailed questions. But I think we're going to go from dams to space and talk to our friends from NASA. So Dr. Carney, Dr. Weiser, up to you.
Great, thank you. And yeah, from one of my favorite shows now for something completely different, right? So, no, but again, I'll try to put the bug in Peter's ear for Launcher to be the maybe next one that we get in these planning programs. But yeah, great. So, hey, thanks, chairs and the, the board for the time today and the invite. We appreciate it. We do have a lot of similarities to how we try to manage our infrastructure and how we attack the problems that are ahead, even though the portfolios are quite different, right? So interesting to see. I'm Joel. This is Eric. He'll pick up my spills and correct me as we're going along. So I appreciate the time. Next slide, please. So just looking at, this is kind of our overarching strategy, right? We start with mission always, and those are approved way up front. Our technical missions, I think we have something on the order of 50 or so. Some of the bigger ones are like Artemis, launch, we're trying to go to the moon, we're trying to go to Mars, and some are much smaller in laboratories and within our science research mission directorate. So we have missions that span across the board, and then therefore we have infrastructure that spans across the board, from launch pads to aeronautics, research areas that are wind tunnels and other scenarios, again, down to the very small laboratories that might be in a building we're trying to take care of. And our approach is to use something called an agency master plan, where we do try to centralize and bring everybody together on the same playing field to move forward and try to organize ourselves and how we make both our investments, but also how we make divestment and sustainment decisions. So how we manage the whole portfolio. This is new for NASA. For 65 years, we existed as 10 separate centers, all trying to execute different layers of the technical mission for NASA. And within the last 2 years, we've centralized and organized. So we have gone to that model. I wouldn't say it's a full operating model quite yet with that centralized organization, but we do have some significant gains in that area. As you see on the slide here, about October of last year is when we got the agency master plan approved, and that was about a 2-year process of bringing all the internal and some of our external stakeholders along to discuss how we were going to manage that portfolio moving forward. Next slide, please. So why were we doing this, and why did the leadership really think we need to go to a centralized model? I think many reasons, which are probably near and dear to many in this room's heart, is facilities beyond the design life. We have over 80% of our facilities beyond what they were intended to be constructed for back when they were purchased. Our previous management model, I would say there's some perception, but some truth to the fact that there was growth, and each of the centers would kind of try to position themselves to gain that work and and execute the mission. And so there's some redundancy that's been built into our system, and we also see some heavy deterioration on our horizontal or our institutional infrastructure, and that's mainly the things that are taking care of each of our 10 cities or our 10 centers. And so it makes sense a lot of times when you're trying to make a decision with a budget that's not ideal, you're going to put your money into where that launch infrastructure is, or that wind tunnel, as opposed to maybe the sewer lines or some of the other things that aren't quite as obviously neat for that. So the chart on the right really kind of shows, again, the why. How did we get there? And it's impossible for you all to see, but those are our 10 centers up the vertical axis, and really broken down by discipline, all the different capabilities that we're executing across our centers. And ideally, all those colors would be green and or yellow heading towards green. That's a facility condition index. And as you can see, very sparsely green areas that are analyzed by Eric and his team as to what the facility condition index is. And we have a lot of reds there, which to me means a lot of risk and a lot of potential risk to execute mission. You see some of the pictures down at the bottom of real world issues that we've had that have been impactful and at least delaying mission, or potentially a safety hazard and things of that nature that have that have come over the last few years. And as OSI, which is the Office of Strategic Infrastructure, Eric and I have been charged with moving this forward and getting an enterprise model that'll work and benefit NASA. Okay, next slide, please. So the answer to that for us was the agency master plan, as I've mentioned. It's got many goals, but ideally it's really getting to a more objective, data-driven, mission-driven, and mission-aligned portfolio. And that's really what you see as the high-level interest in getting us aligned. And we'll talk a little bit about how we got there. And this agency master plan will drive all of our decision-making. It'll be the reason why we invest, divest, and make the decisions moving forward. We have 5,300 assets across all of our 10 centers. So it's a lot to manage, and so there's some right sizing that we are working on, as well as how do we manage and apply the resources to the most mission critical assets that we have across our centers. You see the goals there on the right. Really, we're trying to make our infrastructure more ready to execute mission and more affordable. We also have some sustainability as part of our things in mind, and resilience planning. We have centers in the middle of the desert. We have centers on the shoreline that are struggling with, Houston's an area that's been hit by recent storms. And so those are all areas that we have to think about how we're planning that future to prepare for some of those natural or extenuating storms that are hitting our areas. Next slide, please. So the result of it, and we could almost talk about this the entire time, is a simple XY plot. So you see every data piece, every data point there on this chart represents a facility, and the red ones are what we call our horizontal or institutional infrastructure, and the blue ones are more of our buildings, our research facilities, our launch pads, and some of the other technical facilities across the board. So what Eric and his team did was go through about a 2-year process to visit every center and to bring all of our stakeholders to every center to talk through every single building and what it means to NASA. And so each of these were about a week-long visit, which involved kind of 3 major operating groups in NASA. One is our technical mission directorates, we call them, which they define the missions that we're going to go take on. Then you have the centers, which are really the execution wing of those missions. And then you have what we call mission support, where Eric and I work, which is trying to tie it all together and provide some strategy and policy to how they operate. So you can see this kind of divided into 4 quadrants, and the green lines in the middle sort of dissect that quadrant. So if I walk you through it, on the high right end, those are our best conditioned buildings, some of our newer facilities, and that line on the vertical axis is what we call mission relevancy. There's a lot baked into that score, but it's simplified here as something called mission relevancy. And so if you're in the top right quadrant, you're a very good facility, super important to mission, super critical to mission, and we're going to maintain or sustain you at the best level we can. If you're starting to creep down to the bottom left category, you're really no longer needed for mission, you're really not that in that good a condition, we're going to get a plan for divestment. And so right now, out of the 5,300 facilities, we have about 800 in that quadrant that we're looking to divest of. And mainly that's demo and remove it from our footprint. Bottom right are some of our better facilities in terms of condition, and so we consider outgranting them. We have an enhanced use lease authority, which is something that's growing, and I'll talk about in a minute. That is a way that we can have partners come in and use our underutilized facilities, and we get a little revenue from that to help with our budget. And then the top left, real critical facilities that are deteriorating or in a deteriorated state. And how do we now invest, repair, put money into those facilities to bring them back up to that high right quadrant. So really this is where everything lies. As you imagine, it gets around the green line. There's some, some
fun arguments that happen around the corner about, hey, no, this doesn't belong in the demo list, this belongs up here, and we sit and have those, right? And so that's part of this process of bringing everybody along and coming to a kind of a consensus about how we operate and manage this moving forward. Next slide, please. So I'll kind of go through each of these quadrants. I mentioned divestments. We have a way of looking at every facility, at every center, and ideally, if you think about, if you look from left to right there, you're going from our high mission relevance to our low mission relevance. And so as you might guess, some of the ones on the right side of these boxes are the ones we're looking to demo. The mission relevance is low. We do actually have some others that are redundant facilities that are pretty mission relevant right now that we're looking to also divest of as well. So a lot of opportunity there for right-sizing our portfolio and saving some annual money in terms of annual maintenance, but also getting rid of some of that deferred maintenance backlog that we have built up over time. And again, 65 years of operating in a certain way, this is not going to change overnight. And so we know that, and we have a plan of about 20 years that this agency master plan is to kind of get us back on the right track. Next slide, please. Okay, I mentioned a little bit about the EUL or outgranting process. This has grown significantly, and we plan on growing it even further. We have Google, Blue Origin, many others working on our sites on NASA land and pulling in actually some proceeds there. The work is sometimes very related, and sometimes it's collaborative, and there are times where it's not a perfect match for NASA, but there's some technical benefit there that makes sense. We're using the same equipment or same facilities in some cases, and this is land that we want to keep. The divestment side, we are considering land that we want to give up potentially, but this only is considered of land we want to keep for our portfolio. Okay, next slide, please. Looking at the other quadrant, okay, so how do we sustain and maintain what we have? We are taking a maintenance approach with our very nice facilities to make sure that we're taking care of the ones and putting the resources, as I mentioned, where we need to. We use a tiered maintenance approach, which is basically another way of saying a risk acceptance. And so we take the least amount of risk according to a cost model that our team has put together to say, hey, if you were going to do every piece of maintenance at 100%, that's what you would do. And so our tier one, our highest mission critical facilities will accept about a 10% risk acceptance in this case, or fund it at 90% would be another way of looking at it. And you can see how we distribute that, and how Eric and his team put those risk levels together each year is based upon our budget. And so sometimes those numbers go up, sometimes they go down, depending on the total budget that we get. And then where we're really trying to drive, and some of our centers have led the way in terms of some predictive maintenance and condition-based maintenance, some things of that nature that are getting us to areas where we're stopping. We're able to detect an error or an upcoming repair before it happens, right? And we know that's a very good thing to be able to do to maintain or increase your maintenance before something fails. It's very cost benefit to do that on our end. So looking at some of the predictive maintenance things and instilling that across our agency is a big piece. We have a couple centers that are really leaning forward, and we're trying to bring our other centers up to learn about how they approach it. Next slide, please. All right, and then how do we invest? How do we make decisions to modernize, to recap, or renew some of our facilities, or how do we prioritize repairs? I think we'll have some questions about that, but we do have a process for how we rank every project that gets submitted, and just went through a process there for capital investment and how we prioritize across all of our 10 centers. We have a process where we evaluate the alignment to this agency master plan and the alignment to mission, and we have, again, an objective way to evaluate all those processes and repairs. And so that's how we choose to prioritize our investments. And last slide is, I think, a wrap-up. But again, we're looking to be more affordable and more ready to execute mission. We've made a lot of progress, but it's been a lot of work over the last couple of years, and we're looking forward to this making some benefits for NASA moving into the future. So happy to entertain any questions. Thanks.
To say that that's ambitious is probably an understatement. That, I don't think I've ever seen anything quite like that, and I don't think I envy you the stakeholder conversations that
Yes.
probably go along with particularly the divestment part of that.
Correct.
Conversation. But for our purposes, you talk about the agency's new master plan designed to guide decisions and investments related to strategic infrastructure. So within the context of that master plan and other relevant NASA processes, how do you evaluate trade-offs between the maintaining recapitalization and replacing aging strategic infrastructure? I mean, you talked about facilities in terms of how they relate to you, but let's talk about the infrastructure itself and the things that you need to get to mission accomplished.
Right, and I think in a very similar way, we're looking at risk. We're trying to analyze the risk to mission of any piece of infrastructure that we have and prioritize it on a more objective way. And so Eric and his team have something called a risk-based repair process, where they do an evaluation very similar to what Peter showed on his schedule of is it going to happen versus how influential would that accident be if it did happen, and so we can prioritize those. But it is a tough issue, and I think it depends on where you stand, what quality your portfolio is in to begin with. It depends on how much you spend towards repairs. Where has neglect happened over the last 20, 30 years? Right now, we're kind of in that stage of analyzing that and really trying to fix some of the near-term issues we have now, with the hope that it will lead to more money being freed up for investments in the future and us being able to renew. But I'll let Eric hop on that one too.
Yeah, so as far as prioritizing and making decisions, we do look at, when we look in the invest category, when we look to renew infrastructure and build new buildings, we try to drive toward affordability. So we're looking at every new building, we need to take down more square footage than we're putting up, and we need to drive toward a more efficient maintenance cost to do the work. That scores us. That scores high as when we look at different figures of merit for what projects we want to move forward with. So that's a critical piece. Joel mentioned the risk-based repairs. That's risk to mission. So the critical piece to those repairs, a lot of it's horizontal infrastructure. A lot of our horizontal infrastructure is degraded. And so we get analysis. We understand the risk to mission, but then we also look at the facility condition assessments. We do those, as Peter mentioned, they do 20% every, so they get through every 5 years. We're about that wrap rate too. We're trying to do it more, We're trying to get more consistent and get better data instead of waiting every 5 years. We're really relying on that facility condition data to help us with our degradation models and really help us to understand when critical infrastructure might be a higher risk to mission, and then we look to invest in those.
So I'm going to deviate from my question. Sorry, Steph. So in your chart where you had your the different facilities that you're going to divest, that you're going to repurpose, and then the ones that were of high quality, that were mission specific. In NASA, like everybody else, your mission changes over time, and you determine what it is that you want, where you want to go, and how you want to get there. And so if you're just looking at the facility in terms of it's got a 5.6 rating according to your own scale, how do you match mission with space and infrastructure? And again, obviously, we're interested from a safety standpoint, but some of those you would have to retool based on the purpose of the mission. So if it's mission first, wouldn't you look at the mission and then the facility, not the facility, then the mission? I just try to understand how that works.
Yeah, I mean, the mission definition is the beginning for us. Of course, we have an initial portfolio. That's what we're trying to manage right now. And so that kind of is what it is. So it is a little maybe in reverse in your mind. Good point. But as we decide to invest and move forward, those would be, mission-driven decisions to invest. So yeah, I mean, we have the setting right now would be that we're trying to optimize everything with respect to mission. So if we have, we rehearse that annually. So that allows for some change in mission, and that could change what, on that vertical axis was that mission relevancy score, and would change where it resides on the vertical axis of that decision-making quadrant. And so therefore, yeah, it could start moving out if the mission's starting to move away. We are looking at some right now, exactly, that are moving out in about 5 years. And how do we disposition those 20, 30 buildings that we have at each center? Is it a new mission going to pick it up? Or is it going to be something that falls down in our mission relevancy and therefore we consider for divestment? So again, it's how that mission changes will dictate how we make decisions and move forward.
The if I could, the mission relevance score is critically important also to our maintenance program and the sustainment piece, because as the mission relevance changes, it changes what tier the building goes into. And unfortunately, our maintenance program is severely underfunded. So we are using a tiered maintenance approach to ensure that the maintenance dollars are going to the most critical infrastructure first. And so within that tiered maintenance structure, we use asset criticality, where we assess every critical system within a building, HVAC, roofs, so forth. And even those are ranked and prioritized. And so a tier one, to that point that Joel showed earlier, where we accept certain risk in tiers, we are making decisions based on the building and the criticality of the assets within a building. And we will either run to fail, we will maintain, we will defer a repair depending upon where it sits. And so mission relevance is very important, and we work with the missions to make sure that we're getting the best data we can.
So you're getting all the information up to central, then making decisions based on what mission is telling you. I think the analogy I'm trying to make is some of the facilities, for instance, within NNSA, they have retooled facilities that were meant for something completely different, but they had the real estate and the space, and their situation is different. They don't have a lot of choice in the facilities that they have, so they have to use the ones they already have. But that causes other risks to both mission and to safety from our standpoint when you're retrofitting something that wasn't designed for that building. So there has to be kind of a connectivity between the engineers that are going to perform the mission and the folks at the top who are making those decisions. So that's the nature of the question.
Sure. And yeah, we do have that. We do have that across the board too, of repurposing. I wouldn't say, our wind tunnels and our launch pads are pretty well there for a reason, although our launch pads do change and our customers do change, and they will make changes that do impact safety and performance at each of the pads. But really where we get into some of the more common repurposing is in our science labs, and those will change. Our engineering labs will change year to year, and they will evolve, and we have to keep in mind of that too. Yeah.
So my last question, I'm going to turn it back to Mr. Summers in a minute. It has to do with FRED, because you guys like acronyms too.
Yes.
So FRED is the Facilities and Real Estate Division in the Office of Strategic Infrastructure. So why did you make the shift, and how has management of aging infrastructure changed under this new model?
There you go.
So it's been about 4 years. We've started implementing, as Joel said, a couple years ago, but the planning started several years before that. The agency decided to go to more of a centralized model. And when that decision was made within my division, we took on more of a leadership ownership role in the sustainment and of the infrastructure. In the past, we were more policy, but became more active in developing strategies and tactical execution of the infrastructure across. Specifically, we centralized our real estate leasing approach, and that was to drive standardization, efficiency, and ensure that we were meeting what the authorizers, our congressional authorizers, had given to the agency when they gave us our enhanced use lease authority. And that's been quite effective in our ability to ensure that we are, as you saw on the chart, bringing in some proceeds that can be then used specifically to maintain critical NASA infrastructure. And so that's what we use those proceeds for, to maintain our assets. We've taken on more of a leadership role in the sustainment, and that's where we are leaning forward into the whole reliability-centered maintenance, tiered maintenance, and really changing the posture at all our centers. Some centers lean forward, and others were still more in a reactive state, run to fail, and that industry will tell you that that is not the right approach to your maintenance program. You want to drive toward a predictive nature, and that's where we're heading. And so through the folks in my division, we're kind of driving that, and we're seeing positive change across the agency, as well as being able to articulate to the leadership and to our stakeholders the value of what we're trying to achieve with our facility and portfolio.
So related to that standardization, have you actually included standardization of regulatory requirements that it's governing how you deal with aging infrastructure, or?
Yeah, so we have, as we've evolved, we have begun to update all of our policies, basically our regulations on how a center will execute their maintenance programs, noting reliability center maintenance, tiered maintenance, doing failure modes effects analysis, all these aspects of what a good maintenance program is. Another key piece that we've initiated that was not prevalent was training. A very big piece that we've taken on is training our practitioners to be reliability maintenance engineers and get their certification. And so that's a very important piece. As you understand the benefits of RCM, our reliability center maintenance, it's easier to sell it locally on the ground, right? And a lot of our contractors who do the on-the-ground maintenance, they're very well schooled in that. And so it's a good partnership between the civil servant side and the contractor side as we execute the maintenance.
Yeah, there's a little investment, just like always, that you have to invest a little bit to get yourself healthier. And so that was the hurdle for a lot of folks to, as Eric said, more in a reactionary phase. And we do have, like I said, a couple centers that have really kind of led the way. Eric's hired on some experts to come in and train folks as well, but we're kind of trying to bring everybody up to that level where they're using and adopting some of these principles that are making things healthier.
What a great lead-in to reliability-centered maintenance. I'd like to ask a few questions concerning that topic. So NASA uses reliability-centered maintenance principles, as you've described briefly, to guide how it maintains strategic infrastructure. So my first question is, what led NASA to implement reliability-centered maintenance principles, and how this has helped address aging challenges?
You want me to do it?
Go ahead.
Yeah, so we've been, to a lesser extent, been doing RCM for quite a few decades, actually. Not at every center, but it was recognized years ago that it was an important evolution in our maintenance program. And we have a reliability-centered maintenance it's not a regulation or anything, but a handbook that we've written, and needs to be updated, to be frank. But it started to help guide our path forward. We have since, in the last few years, really put the hammer down on where we want to go with RCM, because RCM is great at, it's optimal it tells you what optimal maintenance you should be doing, right? So it helps you to understand what maintenance you should be doing on a system. And in some cases, run to fail might be an acceptable solution. I'm not a fan, but that is an acceptable solution for certain assets. But it helps us to drive toward affordability and availability of those facilities. What's critical to us is ensuring that the facility is available for the mission. And so being proactive, going and evolving to predictive maintenance with online condition monitoring, condition-based maintenance, PT&I, and things like that, and even going beyond that is where we're heading. It helps us to understand the health of our facilities and the degradation rates, and understand when it could impact mission of facility. And so RCM is helping us get there.
That's great. Thanks for the explanation. You raised an issue that I'm always concerned about, and that is the strategy of run to failure. So I will ask, one concept that you mentioned in reliability-centered maintenance is run to failure, which is an approach where components are allowed to operate until they fail without any proactive maintenance. So does NASA use a run to failure strategy for maintaining any of its assets currently?
We do. So in general, we try to do all the preventative and predictive maintenance that we can. But through a risk-based approach, we do identify assets that can be a run to fail. Some assets, it makes more sense to run to fail than to do maintenance on it, because it's just cost prohibitive. And so it's, like a light bulb. You're not gonna do anything. You're gonna let it run to fail. And so we do have systems that we've done. Now, we are also challenged by our budget, and so that drives other things that we would like to be more proactive on into a run-to-fail posture, and that's where we're accepting risk, and it's not ideal, but we have to do that, and it's all based on risk and risk to mission and life safety. Obviously, life safety is number one, and so yeah, we do make those trades locally and at the agency level.
Thank you very much. So Chair Connery, at this time I'll turn the proceedings back to you, ma'am.
So we had scheduled a break until about now, and I'm going to call an audible if it's okay to skip that break. So we're going to go straight into the discussions with this panel. Oh, that's where the yellow sign is. So we're going to skip that and go straight into the panel discussion. If anyone needs to take a break, please do so. We'll take a little break after that before closing, but we want to make sure that we maximize your time since you're here and get to the good stuff. So I appreciate your taking the time, and we're going to go into the panel discussion. I'm going to turn it over to Mr. Summers to start.
Thanks, Chair Connery. So Mr. Smith, Mr. Dodgen, Dr. Carney, and Dr. Weiser, at this time we'd like to address our questions to the entire panel, all four. And I'll start with the first question. So the first question is about recent successes and significant challenges as infrastructure regulators or operators. So the question is, as agencies responsible for regulating or managing strategic infrastructure, what do you view as some of the biggest successes that you've achieved in infrastructure management in recent years, and what are the major challenges that you are focused on moving forward?
I'll go first. So one area that we kind of consider as both a challenge and a success is risk-informed inspection frameworks. So what I mean by that is using risk information to right-size inspections of various components. Basically reducing the number of inspections while maintaining adequate protection of public health and safety. One success that we've had is in the area of risk-informed in-service inspection for certain piping systems. That kind of is a methodology that utilizes PRA information to highlight those areas of the most risk significance so you can focus your inspection resources on those areas as opposed to some of the others. We've done this for a couple of other components as well, but the challenge comes in to when you have certain components aren't really characterized well in the PRA, such as you can't get good PRA risk information for those. Another area of challenge is there's always the unknown future aging mechanism that could pop up. We've been identifying these for a number of decades now, and there's always the potential for something new to happen. For example, 2 years ago, the French identified some cracking in some of their primary system piping, similar to reactors that we have here in the U.S. So we actively followed that issue. We discussed the issue with the French, got information from them. We interacted with our industry here. They did an evaluation themselves. We did an evaluation. Ultimately determined that that issue really isn't an issue here for various reasons. But it's issues like that come up that always have us scratching our head about how far can we go in reduction in inspections. One success, I would probably call it an ongoing success, is the Gall report itself. We were able to take it from the original report for license renewal, modify it for subsequent license renewal. It's being utilized by most every plant in the U.S. right now. It served as the original basis for the development of the IGAL program at the IAEA, so being utilized by a lot of regulators around the world. So I see that as kind of an ongoing success. There is a future potential challenge, and that's operation from 80 to 100 years. It's not something that we're actively preparing for right now, but it is something that we are starting to look at. We actually have a conference coming up the first week of October, looking at if there is an interest in going from 80 to 100, what research do we need to do to get ready for that? How we might need to change our Gall report to address other issues. So that's some of ours.
Go ahead, Peter.
All right. I'll stay in line. A couple of, well, I'm going to give a success. And, I mentioned there's kind of two contexts for the risks that we manage. There's this high consequence, low probability dam safety related. I want to call that out. It's not my program per se, but I interact with that program a good deal as a success. When the Corps really started digging in to our inventory years ago, it wasn't a pretty picture because I mentioned that we've been building dams through a century or so. And so when we started doing these failure modes analyses and really trying to inventory our entire portfolio and the failure modes that were unreasonably likely, the inventory of needs, the requirements just continue to grow. And in recent years, we've been chipping away at it pretty steadily. Recent years, we're actually starting to hit the crest of that wave, and we've begun to see that we are resolving more of these issues than we're identifying. And so we're on, I don't know the word, it feels good to have turned that corner, and it is conceivable that we could, we could continue to reduce the requirements inventory of those high consequence. So, for a long time it seemed insurmountable, but steady pressure on that has borne fruit over about a 10 or 15 year period. So that's encouraging. The challenge, I'll just offer one. There are so many, but I'll offer one, and that is right now, for about the last 15 months, the Corps of Engineers has been trying on the intermediate risk side to create a full inventory of all of our maintenance requirements, believing that, as we were maybe talking before this, that there is there's an appetite among stakeholders to know what the full picture is. And so the Corps is attempting to build a 5, 10, 15, 20-year life cycle plan for all of our infrastructure, and we're doing it. We are doing it, but it's proven very challenging to first get a collection of all these needs from our hundreds, thousands of sites and many thousands, tens of thousands of mines to kind of think in a specific way, because as I mentioned, that you need an asset registry to integrate information across different domains, and you need a sort of stylized way of communicating through the information systems for it to make any sense. And so we're finding that to be very challenging. Obviously, if we're successful here, we can create long-term plans and begin chipping away there's a lot of moving parts when you get into planning for maintenance of facilities and all the detail.
Yeah, and I would just add for us, I think we mentioned it a few times, our council, one of our highest councils at NASA is the body that we run these processes through and get approval to move forward. So we talked about agency master plan approved in October of last year. The CIPP, which is our capital investment prioritization process, that was also approved recently. Stand-up of our real estate contracting officer and the way we manage and centralize our real property. Those are all big successes over the last year for us to kind of get those approved. And again, as I mentioned, bring it all through with our leadership. And so those, I think just be able to provide a path to success a little bit, right? That's something I think, I think we all, like I said, had 10 different groups all knowingly trying to do the right thing and go in the right direction, and just bringing us together as a team and as an agency to provide a path to success, I think has been something that's good for all of us to kind of get behind. Challenges is like change management, right? It's just back to some of the old standard things of how do we get some of these new ways of doing business that Eric and his team are bringing to NASA, and trying to show everybody the benefit and bring them along, and not always easy to change how they're doing their day-to-day job when, everybody's doing what they think is right and in the right way, and we can use that and add, some of these other strategies to make things better. So, and, obviously budget could help accelerate us getting to success. But, those are some obvious ones for us.
Thanks. So I'm going to ask the next question, and we can reverse order if you would like, just to go in the other direction. Sure. So you all discussed specific requirements for managing critical assets, and they kind of variations on a theme, I would say. So how do you think about striking the right balance between establishing clear, standardized requirements versus allowing for tailored implementation of aging management requirements at different sites, plants, or facilities? And I know for you that's also difficult because you're giving them all different assignments.
It very much is, and we want to allow a little of that freedom also. So again, managing, what we'll have is, I'll explain, maybe a big project will potentially have 40, 50, 60 facilities that they operate in, and it's kind of a single line of business, and they manage and they optimize and they work the best they can with their facilities, with some guidance from Eric and his team about how they, again, where their tiering is and how they should adopt some of the strategies. That is a lot different than a center who has maybe 40 different science projects or programs going on in 2 buildings, right? And so how do we do some more cost sharing, and how do we get everybody on the same path to managing that facility together? So we really have to allow some of the centers to execute, with our strategies in mind, to get there the best way they can. But they're going to have to do it a little bit differently at each of our venues, just because of this, the nature of the work. So, and it does look different in how we contract it out and how we, incentivize those, but also how we, share our facilities together. So we really need to be unique across the board.
It's nice to be in the middle and get a chance to think about these things.
There is there's a need for a lot of dexterity throughout the hierarchy in an organization. You have business line managers or financial managers that kind of hold the purse strings, or have control of the resources at higher levels, and they have to rely on like this stylized information, this portfolio level information, but they also have human connections within their communities, right? They know more than, sometimes they know more than the data tells them, and so you've got to have a system that allows the folks at that level to exercise some dexterity. And then at the facility level, it's the same situation, except that they're in contact with the actual assets. Where they're implementing maintenance interventions, they've got a sense of where the risks are that might even defy our strategic monitoring techniques. And so what we're trying to do is thoughtfully provide accountability in both domains, in the sort of portfolio level domain and at the facility level domain. It's difficult, but it can be done so that there's accountability for performance and for reliability of the facility, in addition to carrying out the process. You also have accountability for performance and reliability of the asset, and that means 90% of the actions are very formulaic, and you could predict it yourself by looking at the metrics, and 10% of them don't make any sense at all. But the facility manager, it makes sense to them, and you need to have a little bit of that dexterity in the system. The same thing at the portfolio or the resource manager level. It's the same way, and we think it's by thoughtful assignment of accountability for those two parameters.
I think I would say from the NRC's perspective, we have like both ends of the spectrum covered. We have the fuel cycle facility at one end, where those regulations are written to be risk-informed, performance-based, and technology neutral, and very somewhat straightforward, because we have less than 10 major fuel facilities, but they're all very diverse. They're not similar to DOE facilities, very, very diverse. And so basically you have your requirements, you have your performance requirements that you have to satisfy, apply the appropriate management measures to ensure that's the case, and continue going on. For power reactors, though, we have like 95 reactors, PWRs, BWRs. No two are identical, but the similarity is enough there that the standardized approach that we've taken with the GAL program has worked really well. The licensees don't necessarily have to create their own program to address it. They can utilize the guidance that we provided, modify it as necessary for site-specific aspects. It makes the review process for us more efficient as well if they follow the GAL program. We are updating the GAL right now, and we put it out for public comment. Got suggestions from the industry to reduce some of the inspections that are included in there, of course. And over time, that's what we've done, going from GAL to GAL SLR, and making this change now. We take those suggestions into consideration and make changes as appropriate. Having a standardized program like that also has some benefits, of one being cooperation efforts. A couple examples include reactor pressure vessel monitoring programs. We've approved one for PWRs and one for BWRs, where they all kind of work together and share the resources for doing the inspection. So they all don't have to do the full program. They can take advantage of other like reactors and utilize their information in those programs. EPRI also comes up with some programs for like reactor internals for PWRs and BWRs, which we've been reviewing and approving as well to make those standardized across the fleets as well. One area that we're seeing now in the subsequent license renewal applications is the utilities using fleet-wide programs for their aging management programs. So just kind of cookie cutter from one plant to the next makes it a little easier for us to review. Makes it easier for them as well to apply across the fleet.
So a different topic, and this is specifically for NASA and for the Army Corps of Engineers. And it is about the topic of risk management when refurbishment or replacement projects are delayed. No surprise. Both NASA and the Army Corps of Engineers share important traits with DOE's Defense Nuclear Enterprise. First, each organization is responsible for regulating the safety of operations, but also responsible for executing vital missions. Second, NASA and the Army Corps of Engineers both face a degree of funding uncertainty and a need to optimize within a budget-constrained environment. So my question is, for the Army Corps of Engineers and for NASA specifically, how do your organizations approach risk management for situations where old, degraded infrastructure is required to stay in service longer than anticipated due to delays in major refurbishment or replacement projects?
I have to go first.
You can't be in the middle.
Well, there's a number of mitigations that we use. I think the maybe the one that's most interesting is the Army Corps of Engineers Civil Works is appropriated annually on a basis tied to each facility, each individual facility, if you can imagine that. So that creates additional troubles for us. So, but this might. So I'll give you an example of what we do, and it might be helpful. So what we do is we have an agreement that we're able to, across those various lines in the appropriation, we're able to hold back percentages of the entire appropriation at a national level to respond to failures. And we typically use that every year because most of our facilities are well beyond their design life, and rehabilitating them is financially very difficult. So I think I mentioned that we do a great deal of small repairs to keep things in operations. But occasionally we'll have a large-scale failure that's beyond the capability of our facility to manage, and we'll use that nationally pooled, we call it 1% funds that we hold back from all the line items in the appropriation to respond to failures. Hope that helps.
So I think similar to the Army Corps, as we noted, the majority of our facilities are beyond their design life, and we can't replace them like we'd like. And so we do refurbish them, and we do monitor them, especially the critical facilities, where we're building the Space Launch System for Artemis to go back to the moon. And so in those situations, we rely heavily on the data we have on the facilities, the folks on the ground who are inspecting the facilities, and as I noted earlier, this risk-based approach to prioritize funding to ensure that as facilities become degraded, that we can rehabilitate them or keep them functioning so that they don't impact mission. That's the key for us, is to not impact mission. We are also, for critical facilities, they're old. So new facilities, as you build new facilities, you can instrument them pretty much as part of the design, right? Old facilities, that's not the case. And so we go in and retrofit those as best we can to instrument them and understand the health of the systems in the building. And we're started implementing data historians so we can collect historical data on the building, vibration data, temperature data, all kinds of data, and we can start to see degradation based on that data. And as the facility or as a pump starts to vibrate out of control, we can send out technicians to check on it and get out ahead of the game and do the repair before it becomes a major repair. So we're trying to be as proactive as we can with those most critical infrastructure, because replacing it is very hard for us to do. We also rely on our missions to cost share repairs. When you think about the vertical assembly building at Kennedy Space Center, it's changed missions from the shuttle. Now we're launching the Space Launch System, the Artemis rocket. That had to do major renovations to that facility. We didn't build a new facility. We went in and renovated several of the bays so that we could now check out the Artemis rocket versus a space shuttle. And so things like that we have to do. And it starts with planning, getting out ahead of it so we meet our milestones.
That's great. Thank you very much. One of the major reasons for having this hearing today is about benchmarking best practices. So this final question I have in this series is about benchmarking best practices. A core objective of the hearing is to look outside of DOE and look outside of that world of DOE in order to benchmark how to respond or how other respected agencies and organizations manage aging safety infrastructure. So as agencies that are also interested in continuous improvement, how do you go about benchmarking best practices that can inform improvements to your operations? And this is for the entire panel, if you would.
Okay, from the power reactor standpoint, we're from a multilateral perspective, we're very active in the IEA's IGOL program. We are currently the chair of the program and have been for a number of years now. We're very active in the various working groups of it. So a lot of interaction with the other regulators that are involved, 30 or so that are involved. So learn how they do it, how we update the IGOL. That can influence our own GOL document as well. Bilaterally with other regulators as well. We routinely, multiple times a year, meet with various regulators, Japan, France, South Korea, to talk about issues that they're coming across and want to get feedback from us, so we can learn from those experiences. Director General Grossi mentioned the SALTO mission, safety aspects of long-term operation. That's what they do it. It has to do with going to a plant that's about to enter into their next period of long-term extended operations and evaluating, are they ready for that under that particular regulator's regime and framework. So we participate in a number of those and are able to learn from those perspectives. For fuel cycle facilities, we're also active internationally. The IEA has a fuel incident notification system. FINIS, had it on one of my slides, so you can see the actual name of the acronym there. But we submit fuel cycle events to that. From that, we can learn from other fuel cycle events from outside the U.S., lessons learned from those. There's a working group that's associated with that meets, I think, annually, so we participate in that and learn from other regulators. I actually learned from some of our fuel cycle staff that there's 2 DOE staff that are going to be joining that working group later this year from EHSS. So, also, I mentioned the NEA earlier. The fuel cycle folks also participate in a NEA working group on fuel cycle facilities, and they are planning to put out an opinion paper in 2025 on aging management for fuel cycle facilities. So that's how we do it. 2025, yes.
So the Corps of Engineers maintains a relationship with the Bureau of Reclamation in the United States, Department of Interior, the State Department, the Southwestern Power Administration, and Bonneville Power Administration. We meet 3-4 times a year to share we call them asset management techniques, but that's what this is. This is, risk-based approaches to managing the infrastructure is basically what we do. So that's our biggest domestic collaboration that we have. Internationally, we have a long-standing relationship with the Rijkswaterstaat in Holland and the Dutch, and we've recently established a similar relationship with the Environment Agency in the UK, which is very similar to the Corps of Engineers, but smaller, obviously. And that's led to, we're also interacting with Flanders and the French in their navigation arena. So that's our main international collaboration. We used to collaborate with the St. Lawrence Seaway for our navigation infrastructure, and we have learned some great lessons from that group, but we found that a broader interaction is better. With agencies that have different types of assets than ours, it's almost like, by looking at an asset from a different point of view, you get better insights, and we gain better. So we're dealing with agencies that have a little more they're similar to us, but they have a little different type of assets, like the Western Area Power Administration. They're entirely power distribution. So,
Yeah, great. And I think on top of that, we have, I think we mentioned several times, we're trying to get ourselves to benchmark our own selves within NASA a lot of times, and some of the centers to learn from others, and so that's a big piece for us. Externally, I think the agency master plan had some of its roots in the Air Force, so our team, learned a little bit about how they approached some of their asset management, and we've incorporated some of their themes into our agency master plan as we were kind of setting forward. GSA has also helped us out with their prioritization process, and not only we do know they also use Builder and other resources, but their how they prioritize their investments is a certain method that I know Eric and his team learned from a little bit and tried to pick up on that and how we manage ours. One of the I'm going to be on my second panel in a couple weeks with the medical community and also the academic community. Very interesting similarities that they have on their portfolio management and the issues and topics that they're dealing with on an annual basis. Very familiar with the federal portfolio management and some of the problems we're having as well. So I know that's one that's an interesting one to talk through and make some acquaintances there and see how they're managing the similar things. So that's another area that I think you might find some interest and some similarities in management. So yeah, great.
Thank you all for sharing those. Chair Connery?
So this is the last question, I promise, and then we'll let you go. This is about the role of self-regulators, and safety oversight. So balancing the imperative of safety with mission demands is challenging, and particularly for Army Corps and for NASA, the role of self-regulation is difficult. How do your organizations approach the responsibility for performing effective safety oversight? A topic near to our hearts.
Yeah, so safety is critically important to us, as you can imagine, putting humans into space. And after several very well-documented failures in the past, the agency is very much, safety is key. So internally, we have the NASA Engineering and Safety Center and the NASA Safety Center and our Office of Safety and Mission Assurance. So we have several organizations within the agency that we partner with to look at facility health and facility safety to ensure our mission success. I think that has been critical to us and critical to the agency and not having repeat failures that caused loss of life. I don't know.
Yeah, I was just going to add, even topics, we talked about pressure vessels, one that's come up in our arena, 2 layered pressure vessels in areas of test and interest in safety. Arc flash is another one with a lot of our high voltage lines. And again, Eric mentioned the Office of Safety and Mission Assurance. Their leadership is within our risk board, of which I'm a member as well. And so we, bring those risks up from the centers, and they identify lots of times their infrastructure shortcomings that lead to potential safety issues that we kind of come together and elevate those if there's a safety or health issue related to an infrastructure problem. So, as Eric mentioned, we're working together, and safety is a very high priority over risk right now for NASA, and that's a good thing. Yeah.
Well, obviously, worker safety is an important issue for us because we have folks walking lock walls and climbing steel structures associated with water, arc flash, electrical, various forms of stored energy risks for workers. So that's an important one I want to mention, but I think we all have that kind of issue. In terms of of self-regulating in terms of our mission and how it relates to the infrastructure. The Corps of Engineers has begun in the recent years to establish for itself some, I won't say objective because they aren't objective, but some sort of standing tolerable risk guidelines, some standing reliability standards for our assets that allow us to cut across, perhaps the willingness to tolerate risks that comes along with a diversity of perspectives and minds. And when you're self-regulating and you're subject to the pressures, the financial pressures and the stakeholder pressures and the political pressures, those kind of guidelines are really a very sobering tonic. So I would say that our establishment of some of those guidelines are probably the best innovation that we've found.
Well, I would like to thank each of you, and I offer my sincere appreciation to our afternoon panelists, Dr. Dodgen, or Mr. Dodgen, sorry, Dr. Carney, Dr. Weiser, and Mr. Smith for joining us today and providing your vast knowledge and experience with managing critical aging infrastructure. I personally found this discussion to be extremely informative and will certainly help us to seek to address the DOE challenges with aging infrastructure. So the panel is excused with our sincere thanks. Chair Connor?
Thanks. So we are going to take a 5-minute break because we know that you all had lunch and coffee and water, probably need a 5-minute break, and then we're going to resume back here at 3:20, no later than 3:20. In order for us to be able to wrap up with our closing remarks, and that will be, then we'll call it a wrap. So thank you, gentlemen, for your contributions, and 5-minute break, be back here at 3:20, please. Hey, if folks are ready, we're gonna get ready to wrap. By that I mean wrap up the session. We are not actually going to attempt any kind of wrapping.
Thank God.
Unless you want to.
No.
Okay. So with that, I will turn to the Vice Chair for his closing remarks, and I'll follow with my own, and then we will adjourn.
Thanks, Chair Connery. And thank you all. Wow, what a great day this has been. We've received a lot of excellent information from the organizations that are represented, and we are greatly in their debt. Our expert witnesses and their organizations have certainly put a lot of effort into understanding the challenges that aging infrastructure present and in developing management approaches that will work for their situations. For example, one clear theme from this hearing was captured well by the GAO experts earlier this morning, and I'll paraphrase: the effectiveness of available tools is bound by an organization's willingness to use them as intended. In addition, I want to bring the focus back to the people who maintain and operate our aging facilities. Specifically, Director General Grossi from the IAEA highlighted the importance of knowledge management and transfer for preserving facility history and practices. Of particular interest for the board is that of our former staff member, Mr. Herb Massey, who is critical in the development of the ANSI 314 standard that we talked about this morning from its inception. People will always be our greatest asset. This is the challenge that we now face. Our staff and the board need to study the information that was presented and consider how best to apply it to our safety oversight of DOE's defense nuclear facilities. We also need to work with DOE to advise them on possible approaches that may fit their various situations. So I'd like to thank the participating organizations once again for their substantial contribution to this topic and for their thoughtful participation throughout today's hearing. This has been an exciting hearing and an excellent hearing overall. I have learned so much, and I can't wait to put what I have learned to use. I also want to highlight that this year represents the 35th anniversary of the greatest safety agency in the world, the DNFSB. Thank you, Chair Connery. This is the end of my closing remarks.
I love following him. Anyway, thank you, Vice Chair Summers. I'm going to proceed with my closing remarks. First of all, I wanted to thank the panelists, not only for your contributions to the hearing, but also for your contributions to the larger scientific and technical community. You've provided the board and all those watching with valuable information and tangible lessons that will help shape our industry going forward. This is a long-term problem. It took us 80 years to get where we are right now in the DOE complex, and the challenge of addressing this aging infrastructure will not be solved overnight. This hearing is a big step in our campaign to explore the good practices other organizations have to offer to assist in an aging complex that has continuing and expanding missions. As I noted previously, the board is taking a more holistic view of aging infrastructure. With that in mind, there's one observation that I would like to contribute myself to these proceedings. We usually talk about aging infrastructure and its potential impacts on facility safety and mission performance. But there's another detrimental impact from aging infrastructure that's even more damaging to the organization, and that's the effect of aging infrastructure on the members of the organization. Workers notice the conditions in their workplace. Old, dilapidated buildings, inadequate lighting, poor working conditions, and frequent equipment failures are some of the indicators that aging infrastructure, and they are keenly aware of it. Those indicators affect workers' morale and their perception of an organization's commitment to them and to their safety. It's hard enough nowadays to hire, train, and retain workers, but when they sense that an organization isn't committed to their well-being, it's nearly impossible. I will close by highlighting a few points that came to mind from today's testimony and plan to engage our staff about it as the board moves forward with its infrastructure campaign. Our first speaker today, Director General Grossi of the IAEA, shared a story of Besnau, the nuclear power plant in Switzerland. While Besnau's plant's began operating in 1969 and continues to operating today, he cautioned that it would be unfair to say it was the same facility. That's because its technology, management, and regulatory oversight have been renewed and upgraded over time. This idea of renewal and upgrade in technology, management, and regulatory oversight has been a through line in this hearing and from our first speaker to our last. And the organizations represented here today have helped point the way forward for renewal and upgrade of each of these critical areas. Here's just a few of the points that I think we can build on going forward. First, the GAO provided thoughtful leading practices that can strengthen the Department of Energy's management of its infrastructure, including lessons that would help DOE maximize its ability to reduce safety risks within the reality of a budget-constrained world. Next, we learned how the American Nuclear Society developed a standard for aging management and life extension specifically tailored to non-reactor facilities like those within DOE. And it was great to hear how several Department of Energy affiliated personnel supported the development of this standard. This represents a significant stakeholder engagement and balance of interest for all end users. There may be elements in this standard that will help DOE upgrade its regulatory oversight. Third, we heard how the Nuclear Regulatory Commission approaches aging management differently between power reactors and non-reactor facilities it oversees. The engineering rigor and technology applied for power reactors is impressive. I understand the difference in the hazards with the non-reactor facilities, but can't help but wonder if some of that engineering could help inform DOE regulations to better execute its mission with improved safety. Next, we learned how the Army Corps of Engineers handles its civilian work infrastructure using risk assessment and management tools informed with properly tailored condition assessments using the best technological solutions available. Finally, we heard how NASA is taking an agency-wide approach on several important management fronts, particularly the master asset planning to bucket investments in enabling infrastructure facing poor conditions. We know that NNSA is working on a similar approach. We also learned how NASA adopted solutions derived from good technology embraced by the agency with rocket scientists, like agency-wide predictive maintenance as part of its embrace of reliability-centered maintenance. There's a lot there, and that was just a quick summary of today's discussions. We look forward to working with the Department of Energy to apply the insights and best practices from this hearing to strengthen the management of aging safety infrastructure at defense nuclear facilities across the country. Again, I'd like to thank our witnesses and their organizations, the alphabet soup of GAO, ANS, NRC, the Army Corps of Engineers. See, the Army's so simplistic, they don't even have an acronym. And NASA for supporting the hearing. And a thank you to Director General Grossi and the IAEA for supporting our efforts as well. I want to thank all of those who attended here in person, as well as those who are watching live streamed, any elected officials and other representatives from state and local organizations who have watched, and our stakeholders across the complex. And finally, we'd like to thank our audiovisual contractor for today, Immersive Concepts, for providing excellent services. The board will consider the information gathered this afternoon to inform any actions we may take regarding these issues. The record of these proceedings will remain open until September 13th, 2024. Members of the public interested in providing comments for the hearing record may email them to hearing@dnfsb.gov prior to September 13th. The board reserves the right to further schedule and regulate the course of the public hearing, to recess, reconvene, postpone, adjourn this public hearing, and to otherwise exercise its authority under the Atomic Energy Act of 1954 as amended. This concludes the public hearing of the Defense Nuclear Facility Board. We are now adjourned. Thank you.